Good morning. Oh, you can hear me? Good. All right. Yeah, thanks for coming. Today's a Saturday. I know that, So I'll try to finish it before 4 as far as possible because I must also have to rush off to somewhere later. Okay. So now all of you attended my first one on the test construction. So this is just a follow-up, okay, of where we left last time. Now, I think when you set test paper is to evaluate students' performance. Have they achieved the learning objectives and all the things there? So that's what it is. But you see, your test paper basically is an instrument for assessment. Is to diagnose them, are they up to the mark or whatever that is. But the thing is that you must make sure that your test instrument is effective, is good. It can measure exactly what you expect. Am I right? If you have a lousy test grade, I suppose that you're going to get much information from the students. So today, we follow up. Now we look at, okay, I get a test instrument. How good is my instrument? Does it supposed to measure, or what? So that is my topic here. It's from questions to insights into the quality of your test instrument and how to evaluate this test instrument. And that's the topic for today. All right, so let me go on further. Now, there are only 4 bullet points, as you can see. These are 4 main topics. And I think that maybe before lunch, I should be able to finish the first 2, is to understand key characteristics of effective tests. What made a test effective? This is my question. Okay? And then, of course, I will go into the item analysis. This is a very basic item analysis. What are they? How to use them? That's the question. Then hopefully after lunch, I'll go into the last 2 topics. It's called the distractor analysis. And last but not least, is to talk about the whole test evaluation, which are the content, validity, and reliability. And this is a very short, by the way, this is actually supposed to be a 30 hours of training. But I only make it for about 5 or 6 hours here. So it's very condensed. And I have to cut out lots of little details, I go right to what you want. That's about all then. Other things I have to leave it out, And I remember when I did this one for the teachers, after a while, they will complain to me. They say, I cannot take it anymore. Now, today I asked you to bring your computer because you'll get a hand busy with a computer. Okay? Don't worry. I think you have received my worksheet. The Excel, okay, I'll tell you how to use it. Don't worry. But you can use it eventually for your actual work, to be honest. But this is only a sample to show you what that is. All right, so so I think we should go into it without further ado. Now, when you talk about test instruments, these are the 3 important characteristics. Oh, sorry, I have your handout. Yeah, okay. I almost forgot about the handout. Yes, thank you. Yeah, thanks. Thank you. Yeah. Okay, there you go. Someone take it. Yeah. Okay, everybody go on. Okay, now, when you talk about good or effective test instrument, these are 3 main characteristics it must have, no matter what. So if you miss any one of them, then it will make your test instrument ineffective in a way. So let me just go through these 3 very briefly. All right, so that's what it is. Now, what do we mean? A valid test. What's the validity here? That means it must measure accurately. Accuracy is quite important when you set a test paper. Now, what do you mean by measure accurately? It's very loose, right? First of all, it must align with the learning objectives. That's a key point. You see, one thing about teaching, assessment, or thing, everything is driven by learning objectives. In other words, you should not go beyond the learning objective. Neither can you go less than the learning objectives. Exactly, you must meet all the learning objectives. Okay, so that's the whole idea. Now, it must assess accurately the knowledge and skills of students were taught. If they were not taught on some of the things there, it's unfair to the kids. Don't try to set the question which is beyond what they have taught. Fair enough? Now, that's one. Sometimes teachers may forget and then just set a question there, and all the kids are crying there, look at scratch their head, how to solve that problem there. Please don't do that, okay? I think it's quite torturous to the kids. Now, hopefully the test can cover the entire range of content. If you have 10 topics there, your test can be just 2 topics and forget about the other 8. Don't do that. It's very unfair. Try to even it out, okay? As far as possible. Cover the entire range of content covered during instruction. If you do that, we call that then your test has what we call the content validity. Meaning the content is valid. I cover everything. Okay, good. Now, you also want to measure their concepts and cognitive processes that's intended. For example, in mathematics, we want to not only that they can understand the concept, but can they handle problem solving skills, okay, reasoning skills, which are required both in math and science. Okay, how about language? How they organize their thoughts when write an essay, for example. So these are the kind of skill. Okay, these are what we call the cognitive processes, thinking skills, problem solving skills. Everything is there. It's a skill you want to access. Skill is quite important in learning. It's not just memorize the fact and that's about all. Be able to explain why something happens, especially for the science. Explain why. Yes, and I'm sure that, in language, we have what the critical reading. You have a for comprehension question there. Explain what the author is talking about this kind of a thing there. Why he will speak about. So these are kind of help the kids to be able to analyze it and explain to you, what they understand in the passage. So these are kind of cognitive processes you want to access. And if you do that, that means your test paper also will construct validity. So, very briefly, this is all about designing a valid test instrument. Now, give an analogy here. If the time is 7:15, but you have another clock, it's always 2 minutes faster. Is it quite accurate? It doesn't. You go faster, it's not the exact time, right? So in other words, your test cannot test beyond what they have covered or what they have learned. That's important, you see? So that's the one thing we have to watch out. It's quite simple. I just use this different simple analogy here to show you what it meant, validity. So this clock is valid, but that one is not valid. Simple as that. Now, not only the test must be valid, the test must also be reliable. So we try to measure reliability or evaluate reliability. What does that mean? A test is reliable. It means what? It must produce what? Consistent and dependable scores under similar conditions. You give a test paper, the kids will do it. But how do you know that your test paper is reliable? If you give them something similar to it, let's say the next day or whatever that is, can they still handle it? So that's the question. It means under similar conditions. So if they can do that, that means you do have some kind of reliability here of your test. Okay? Now, so in other words, if the students were to take the test under similar conditions at another time, their performance should be relatively similar. If you get something, let's say 1 week later, similar to what they have done a week ago, can they produce some, will the test score be quite similar? If the test score is heaven and earth, something must be very wrong. How can it be that? It's quite similar, right? But the result comes out to be totally different. So, in other words, when you see that kind of a situation there, that means your test may not be quite reliable. So just give a very simple illustration. Now, what are the things that are reliable what kind of measurement is reliable in our everyday life? Now, look at this scale here. In morning, this is your weight. Afternoon, this is your weight. Come on now, do you have a reliable scale? Something like that, right? So let me give a simple illustration here. So that's one reliability. You know, look at it, then you will know. Fair enough. All right. Okay. Now, okay, the test must be fair. Now, that's one of the things we have to be very careful about, being fair. Sometimes we may overlook, you know. It must provide equal opportunity to all students to perform well, not favoring or disadvantaging any group. For example, the background, you have to do that. If you have to set the questions on 4 seasons of the weather, sorry, the kids don't understand 4 seasons here in tropical country. Am I right? You don't do that. Also, a certain festival which is not celebrated in Malaysia, because what is that? So that's the reason why it's being unfair to the kids, because they know what that is. It may favor certain group, but may not favor another group of people. That's called being fair. Okay. Gender. Don't stand toward the one gender and then forget about the other gender. Okay. Yeah. There are only 2, male and female, as far as I'm concerned. Okay. The cultural difference is quite important. So usually we must take into context of our culture here. Don't give a culture overseas to the kids. Okay, I don't understand. What kind of culture is that? So that's why you see in all the textbook, I still remember when I wrote textbook for the publishers, and also, which country am I writing for? Simple thing, even like the currency that we use. We must use the currency of that country, not Singapore currency cannot. You use that country's currency. That's what it is all about. Even the measurement and everything, use that type of measurement, whatever that is. I still remember when I wrote the math textbook for the US market there, I must use the imperial system of measurements. Yes, they still had the metric, but I must still use the imperial. How many feet, how many yards, how many pounds. They will still do that, by the way. No choice, I have to do that. So background is quite important, okay? So the cultural difference is there. Now, an unfair test, what happened? It will undermine the credibility of the test. Fair enough. Because you penalize the kids unnecessarily. Now, I think in this world, of course, lots of things are quite fair. You have a blood test, the same blood test for everybody, right? Regardless of race and age. Gender, so it's very fair. When you take a blood test, the test will come the same. Same as you do some measurement using the measuring tape. It's the same. There'll be no change. So these are fair instruments. Am I right to say that? It's a very fair instrument. So things of this sort. Okay, give us some analogy here. Quite simple. The 3 characteristics of the test. Now, so this is only the concept of it. Okay. Now let's go further into it then. Now, okay, this is the gist of it now. We come to the item analysis. Now, in item analysis, you have a test script. Your test script has many test items of different types. You got MCQ, you got short answer question, you got essay question, you got all kinds of things there. So different types of test items here. And now we're going to look at how are we going to evaluate each and every test item. Not some, but each one of them. If your test script has 10 items, we evaluate all the 10 of them. You follow me? So that's the whole idea. So because of that, we will use statistics to analyze. We apply it to the test items. Now, apply to where now? That is where now. While you evaluate students' performance, their responses to your test items will evaluate your test instrument, how good it is. So we are using the students' responses to the items to assess the quality of the individual test items. Of course, that's not enough. Sometimes we also have to have some expert judgment there. Fair enough. We invite some expert, look at it. What do you think about these test items? Okay, so we got 2. We apply statistics to analyze and to look at the test items. At the same time, we also try to call upon some of the experts to look at the test items. All right. And see which items are effective. If they do, keep them. Just good why? Keep them. Not so good one, you may have to refine it or even to replace it totally. You see that? So that's the whole idea about item analysis. Now today you're going to do some item analysis here. You see, if you talk about the quality of a test, basically there are two views of it. We talk about the item analysis, right? You're looking into the little details into the test paper there. It's like looking at the microscope, look at all the little things inside, you know, maybe it's a living cells or maybe the bacteria or whatever that is. Very minute. This is a micro view of the test. But at the same time, you're also like flying in an airplane there, you have the global view. That means you look at the whole test. The whole test of it. So now there are two parts of a test. The test has both the micro view and the macro view. Combined together, we look at the whole test, is it effective? So bear in mind, we have these two views, you know, when we talk about evaluating the test effectiveness. So much for this brief introduction. Let me just go on now. Now we go into the actual evaluation of the item analysis. I will talk about only these three characteristics of the test items here. The first one is the level of difficulty. That means what? How easy or how difficult a test item is. In other words, what we want is that we want to ensure what? The test must be a balanced test. Am I right? Balanced test. A range of easy, moderate, and difficult test items, catering to all levels of students. You can have all very difficult or very easy. It must spread out. That's important. Okay. The next one is called the power of discrimination. Now, in the class there, you have some very smart Alex, very fast learner. This is a good, high performance. You got not so slow one, not so good. I call it a low performance. Fair enough. So, can your test items be able to discriminate these two groups? Can see the difference between these two groups of students, and that's called, you know, it's called the power of discrimination. In other words, can the test effectively separate high achievers from the low achievers? That will also contribute to the overall reliability of the assessment. The whole test item, can they differentiate it? Last but not least, how good are the distractors? Now, this one applies to what? To the MCQ questions. The quality of an MCQ depends on how good the distractors are. That's important. Okay? This is only for the multiple choice question. So, in other words, a good item depends on the effectiveness of the what? Of the distractors. Actually, to be very honest with you, constructing MCQ questions can be the harder one. I've ever done once for a group of the preschool teachers. I test a paper there because I was teaching them about assessment. So I must practice what I preach, in other words. And so when I set the question, there are the different types of test items. There I got MCQ, I have the short answers, I have essay questions, you know. But when I go through that, when it comes to the MCQ side, it really spends lots of time thinking about what kind of distractors should I put in? Maybe A, B, C, D. Of course, one is correct key, fair enough. The other three are the distractors. These are what they count. So we do look at it. How can we evaluate the effectiveness of the distractors for MCQ? Okay? Fair enough. So far, so good? Okay. Okay, now come to the actual measurement. We talk about the level of difficulty, right? So there is an index. It is called the difficulty index. Now, we want to measure. This is a measure, by the way. How easy or difficult a test item is for students. Okay? Its purpose, help you to assess appropriateness of the test item. Ensuring what? They are neither too easy nor too hard. And it must align, see? It must align also with the learning objective. This is important. We never leave the learning objective, no matter what. It's always there. Okay? So, in other words, the difficulty index represents what? The proportion of students who answer correctly. Now, let me just look at, that's what you would do in the calculation. How to calculate the difficulty index? I use the P, the letter P to stand for it. The range is between 0 and 1. It's almost like a probability, okay? But it's a proportion, fair enough. Actually, probability is also a proportion, to be quite honest, okay? In other words, it's quite simple. What you do is you take the number of students who answer correctly divided by the total number of students. Very straightforward calculation. Now, of course, you get a value for P, but how to interpret the value? Now, I give you the range here. If you come out for that test item, if the range is not more than 0.3, that considers a difficult item. The majority didn't do well. Only, a few of them can do well. Okay, so that's basically what it is. If you have it between 0.31 to 0.7, it's called a moderately difficult. And this is the ideal range. Good. You have something in between. Not too difficult, not too easy. They can do that. If you go beyond 0.71 to 1, you keep away the test item. Everybody can do it. They're quite happy because they all pass with flying colors with this test item here. So these are the things you can do the measurements. Okay? So this is called the difficulty index. Now, I'll give you one simple question here. Suppose an MCQ question answered correct by 40 students out of 100. But the MCQ is easier to mark, right? You either have 0 or 1. 1 means correct answer, 0 means sorry, it's the wrong answer. So it's quite easy. You can see that, your P, if that were the case, you will take the total number of correct answers, number of students there, divided by the total number of students there, 0.4. It shows that this question is what? It's moderately difficult. Look at your handout here. 0.4 means what? 0.4 is this range. Am I right? So that means, yes, it's good. It's going to be moderately difficult. You have that. Now, one thing about using statistics, you want to have a large sample size. Now, I know that Andrew said because the class can be small. You may not have the sample size there to make it up. So I've been thinking about that, how to make this statistic meaningful. Because instead, if you have too small a sample size, even you can calculate all this thing here, it may not be so meaningful. Perhaps if you start with 20, 30, it will give some good meaning. But the more, the better, put it this way. And I was thinking about this for quite some time. I don't understand one thing. Apparently, the test paper set here in EduSeed is being used by all other centers. Am I right? That's what I heard. They take a paper, because over there, since the teacher don't set test papers, In terms of what you have, pass to them, they'll just put it there. So, hey, that's a good idea, though. In that case, maybe I would why not you want to consider this? To take the responses to the test paper from other centers and merge your class over here for the same question, but for the same test paper. Then you have the big number there, right? Let's say you can take from center A, center B4, wherever they are, put together. Now you have a big sample size. I'm sure they can put together, you can get at least about minimum 30. You get 30 of them, that's a good sample size to begin with. 100 is better, but if you don't get 100 there, it's fine. Just get about 30 to start with. That's a good way to look at it. Now, once you have that, you look at the test items and say, okay, is this good or not so good? Test items. You see that? So that's one way of doing it. Fair enough? That's okay. Another way, if you want to do it, if you use the same test items over the years, you can get the data from the previous year, for the previous years put together, and see how students over the years respond to this one test items. Then you also got the numbers there. Am I right? So try to make the sample size as large as possible. All right. Now, I'm talking about MCQ. How about those short answers? With short answers, you got partial credits. It's not just 0 or 1. Maybe you have something like, 5 points or short answers, right? So people, they can score from 5 points, or 4 points, or 3 points, or 2 points, 1 point, or 0. Fair enough? You got a range of possible scores that they can. Now, let's just give you a scenario. Suppose that you have, 20 students here, right? And out of the 20 students for this particular test item, this is with partial credit. Let's say 7 of them get a full credit, 5 points. And none of them get 3 points. And 4 got 0 points. Everything wrong. Now, how do you compute the difficulty index? What you do is that you total up all the points, correct points, okay, from all the students here. Add together, whatever that is. Now, look at the denominator here. You take the maximum possible points. In this case, it's 5. 5 times the total number of students. So if I do it that way, I get 0.62, which is a good range. It hasn't gone beyond 0.7, so it's still moderately difficult. You see, that's how you do it for this kind of. So it's very good for MCQ. It's very good for the short answer questions. So far, so good? All right. How about for essay? Short essays, whatever that is. Or they will write a short paragraph or whatever that is. Let's say this essay question is worth 20 points. Now, of course, you break down your 20 points because you have the scoring rubric, right? You break it down, okay? If you come to this one, how many points will be? These are the partial credits. So what you do is that you get 20 students, will score somewhere, let's say, 15 to 20 points. And 4 score between 8 to 14 points. And 3 is below 8 points. Now, what you do here is that you don't add up all the points, but rather, what is the average of this thing? Take the average here for the 20 students and see what's the average points for the 30 students. And do the same for all the others. Excuse me. Then you can take the average here, then you can take the total number of points, scored by all students here, just multiply it out by itself there, and you can see, how to do it. And you can see that, the average is about 18, right? So it's 18 times 13 plus 4 times 12 plus 3 times 6. And you divide it now. It's the maximum number of points, which is what? 20 times the number of students, also 20. I'm talking about 20 students here. So it'll be 20 times 20. You will get a 0.75. That is an easy test item for essay. That's how you do it. Yeah. So you can do it for the essay test items, you can do a short answer test items, or the MCQ, whatever that is. I think I pretty well covered most of these different types of test items here to calculate the difficulty index. So far, so good, huh? Okay, you can do it, huh? You do. Your PC now. You have this spreadsheet, the first one, MCQ. Look at your MCQ here. Now, okay, let us look at the how to calculate the difficulty index. You have it, okay? All you? Now, here you can see that I got 20 students here. Okay, and altogether are 15 test items. Hello. And let's say you capture all the points. Now, by the way, say MCQ, you only have what? 0 or 1, right? 1 is the correct answer, 0 is what is incorrect answer. Quite simple for MCQ. So what you do is that you have tabulated all the scores of students for 20 students here for all the 15 test items. Now, what you do is that the spreadsheet is a very good tool, by the way. You don't have to do it manually. You first of all sum up correct responses. How many? You know how to do it? Are you familiar with the Excel functions? You have sum, right? Sum up. All right, quite simple. Because 0 plus add all together, and you put it here. Fair enough. So you straight away you can just duplicate all this for the whole row. Then you know for all the 15 test items here, what are the corresponding correct responses? You can calculate that one quite easily. Now, once you have that, the next one is quite simple. You take what? You take this one divided by what? How many? 20. Am I right? And that's it. That will be your difficulty index. Easy? Now, come on, you just do it. Come on, just do it and see what you have. Now, if you're not sure about some of the Excel functions, just help each other, okay? Just talk to each other and say, okay, what are the functions to use then? Then you can figure it out. Yeah, you can fill the P, yes. No, later. I can't come to that one yet, the D later. Okay, just the P first. Do the P first. Don't forget about the D, yeah? I haven't come to the D yet. What do you have so far? You give me the first one. What's the first one? 0.95? No. What's the P? The P value? 9, is it? Is it? 9. 9, yeah? Second one? 0.5. No. It's this one. 9 over 20. 9 over 20. What's the first one? P. I want the P value. P value is what? It's a correct responses divided by 20. Hello? Am I right? So the first P is what? The first one? Yeah. What's the answer? I just want to answer so far. Next one? Third one? Okay, that's it. Okay, I'll just stop here. You got it? You get this line here. This is the total number of correct responses divided by 20 is for this one here. Okay? You got it? You got something like this? Hello? Okay, now look at it. If you see this kind of a score, for example, what can you say? Is this a good test items? Okay, yeah? This one? Very hard, right? Too hard for the kids. You see that? So you will know how it is like. You see that? This will give some indication. Now, once you see that, what happens is what? Then look at the test item. Do you need to do anything about it? You will think about it. You may not have to replace it. you may have to refine it to some extent. So you either refine or you replace. Fair enough. So it's a good indication to show you. Now you work out any one which is very easy. Which one is there any one which is very easy? The P. Any one you get is the beyond a 0.7. No. Anyone beyond 0.7? Anyone? None, eh? Okay, good. That means this teacher set a pretty good MCQ question here, except a few exceptions here and there. Okay? Fair enough. Yeah. So that's how you can, so that's one way you can evaluate the difficulty level for MCQ. How about for short answers? You have this one here for short answers? Now, again, I've got 20 students here, okay? Now, I've got 20 students here, and these are short answer test items. Again, each test item maximum point is 5. Okay? I can pass the credits from 0 to 4. So these are the scores here. So, how do you do? This one is the same, by the way. Can you just sum up the total number of correct responses? Right? How many of them? Then you divide it by 20. Again, it's the same thing. And you get the answers. This is how you do it. This is how you do it. Okay? Divided by what? Divided by what? 20? Now, divided by what? That's important. What's your denominator now? Okay, now that's the question. How to find your P? What's the P here? It's the total number of what? Correct responses, all right? How many? Okay, add all the points there. Am I right? Add all the points there. Divided by what? 20? Maximum point for each, for this test item, is 5 times number of students, which is 20. That will give you the answers. See that? Be careful. That's how we do it. These were the short answer questions. You got it? All of you? Yeah. It's not difficult to calculate all those things there. Yeah, feel free to ask me the question if you are not sure how to do the calculation. Don't divide by 20 though, okay? It must be 20 times the maximum number of points for that test item, which is 5. If your short answers have different maximum points for different questions there, then you have to change this number accordingly. Let's say your next short answer is about 7 points. It will be 7. So this is not fixed though. This one depending on that particular test item only. That's important. Okay. So far, so good, huh? Okay, good. Okay. We come to the next one. It is called the discrimination index. Now, What's the purpose of trying to evaluate the discrimination index? Basically, I want to see what? How well a test items can distinguish between the high-performing and the low-performing students among them, the two groups. Okay. So, in other words, a good test item should be able to answer correctly by more often by the high scorers than by the low scorers. Ideally. But sometimes it may not be the case. The low may score higher than the high performer. Something must be wrong somewhere, see? So now, that's how after that, okay, now, I'll tell you what you will do now. It's a bit complicated here. First of all, you get all the test score for this one test item here. You must rank the students by the total scores of the test. Not about the total test score of that test item. No, it is not. It's the whole test paper. Whole test paper. Rank them. Then, listen very closely. Step 2, you identify among all these students here, you find the top 27% and the bottom 27%. Roughly around there. Roughly. Okay. It's not exact because you don't have half a student there, am I right? So it roughly take. Let's say if you have 100 students there, it'd be what? 27 on the top, 27 on the bottom. But you got 20, it's hard to divide. But no. Okay, so you take this one here. It can be somewhere between 25. Actually, they said the range should be about between 27 to 30% around that range, or even 25. But don't go any lower than that. Why? Because if you go lower than that, then this discrimination index may not be that meaningful anymore. So we try to keep it, and again, rightfully, you should have a large sample size. It's always the case. In statistics, you cannot run away from the large sample size to be meaningful. Am I right to say that? So, as I say, you can take from other centers. Again, for this test item here, put it all together, you get a minimum of 30, you can get it going meaningfully. Alright, so after you identify the top 27% or the bottom 27%, then you start calculating the DI. We call it the DI, discrimination index. Now, of course, like anything else, we must interpret the results. So these are the steps that you will do. Now I will show you what that means. Here is a little formula here. I'll use a capital D to denote this discrimination index. Now, the range of value in this case, it can go from -1 to a +1. It's not 0 to 1, but -1 to 1. That's important. So what you do is that you work out correct responses in the top group, the top 27%, and you work out the correct responses in the bottom group. You find the difference. You divide it by the number of students in one group. Now, by the way, these two groups have the same size. You don't take all the students there. No. These are students only for the top and the bottom group. Let's say the top group is, let's say about 20. This will be 20. Because the top group 20 will also be 20. So it's the same number for the denominator here. Am I right? So that's one of the way of doing it. Or another way is that you can use the difficulty index to calculate the difficulty index of the top group minus the difficulty index of the bottom group. Is the same thing. These two are equivalent formula. So you can use either this one or that one. It doesn't really matter. All right? Yeah. So that's how you do it. So clear about the formula? Now let's how to use this formula here. Now, first of all, let's look at how to interpret. Let's say you get some results. Okay, something like this or something like that. Now, Let's look at the extreme cases. D is equal to 1. Now, look at it. When D is equal to 1, look at the formula. What does that mean? Now, look at the formula, you will know what it means. When D is equal to 1, how can you get 1? That means what? Let's say you have about, let's say you got 10 students, right? All 10 answer correctly. Fair enough. So, you got 10 here. Okay, you got the marks here, okay? Minus what? All get it wrong, 0. So when you do that, you got a 1. Am I right? So it's very good. This is a perfect test item to be able to discriminate the top performers from the low performers. But in reality, it's very hard to get this because no matter how bad the low, they just can get some right, usually. Am I right to say that? Okay? Fair enough. Now, I want you to be very clear about how to interpret all these results. If you get 0, how do you get 0? It's quite simple. 0 if this number are the same, right? Top group, how many score correctly? Let's say you got 5 score correctly. Your bottom group also have 5, so becomes 0, right? So 0 minus 0 is 0. Divided by any number there is still what? 0. So 0 means what? You cannot differentiate. The test item failed to distinguish the performance of these two groups of students. So it's not a very good, test item here because it cannot differentiate or discriminate them. Okay. Now, if it's a negative, now that's the worst thing. Negative means what? That means the bottom group performed better than the top group. Now, there can be many reasons why. I tell you, it can happen. You know why? Sometimes when the bottom group perform better because they know better, because they guess better. Oh, I got it right. But the top group, very cautious, right? Look at it very carefully, am I right? But sometimes your wording may confuse them. Not mislead. What do you mean by this? I'm not sure, right? As a result, they make lots of mistakes. You follow me? So being careful, yet they make too many mistakes. The bottom group, I don't know, I just guessed my true. Happily, I got it right. So that can happen. So in that case, that means that's not a good test item though. You do something about it, okay? Maybe your wording, may mislead them, to a different understanding. So you have to rephrase it or whatever that is. So this is a kind of a thing there. Now, the ideal range will be this one here. This will be the good ideal range. Okay, this is a very extreme, either 0 or 1 or negative. We try to avoid it as far as possible. But 1 is a good one, by the way. 1 is really good. Okay. Now, but in practice, I think most likely you will get something like this. It's between the 0 and the 1. Now, if you can get anything which is what? Greater than 0.4, is an excellent discrimination. Good. Okay, anything like that. From 0.4 onwards to 1 is a good range. If you have something in between, 0.3 to less than 0.4, it's still a good discrimination. It's still good, nothing wrong with it. Okay? But if anything which is lower than that, from 0.2 to 0.29, it's considered what? Acceptable. It's just past that, acceptable. I can accept it. But maybe you have to do some minor revision of the test items. It's up to you. But all this is no hard and fast rule. It's up to very much of the examiner. Look at it. Because there's other factors which may affect the one who's selected, I may not want to change it for whatever reasons. Fine. That's why you need expert view. So besides calculation, you need expert view. Ask me, look at it, by the way, look at this. What do you think of this test item here? Help me to understand, is there a need to do further revision of this test item? But however, if your D is less than 0.2, that means what? This is a very poor discrimination index. So in that case, I think you need to revise it or even to replace it. See that? So this will give you some indication whether or not a good item can really distinguish the top performers and the low-end performers there. Now, start with a simple one on MCQ. Let's say that this is one MCQ test attempted by 40 students here. I'll take one test item, okay? let's say that I get 8, the top group is 8 of them out of 10. So my size is a 10, right? So 8 out of 10, the score correctly for the top group. The bottom is what? 3 out of 10. So it's easy to calculate. You can see the difference, right? This is the what? This is the total number of students who got it right, okay? Minus total number of students who get it right for the bottom group, divided by 10. And that's how you get it. Be careful. The 10 is only referring to this 10 here. Not all the students, only for this 10. Okay? Yeah, it's the size of the top group or the size of the bottom group. How about with partial credits? Short answers. Now, that's where you take the average score on the top and the bottom. Let's say the test item is maximum it is 5 points, okay? Then you take the top group, you average it out, let's say you get 4 points. That's why you will get the 4.5 for the top for the top group students there. At the bottom, you get 2.7. Fair enough? Again, you take the average score of the top group minus the average score of the bottom group. You do a division there. And divided by the maximum score of the test item. In this case, it's what? It's 5. Am I right? It's 5. So you find the difference here. And you get this one here, which is considered as what is a good discrimination here. You can really tell the difference between the top and the bottom group here. Okay? And the same approach, by the way, I won't do it. So same for the essay. You always take the average, by the way. That's important. Take the average of the top group, the average of the bottom group. You find the difference. Divide the maximum number of score of the test item there. For the essay item, it's the same. Clear? Okay. If you are clear, then you can work on the same worksheet for this one here. All right. Now, I think that you do not have the total score. Am I right? It's blank. Your total score is blank, right? I give you the total score. Just a minute. I give you the total score. I should have the total score here. Okay, I tell you what, I will do the sort. No, wait. This has been sorted already. I should give you the score. Just give me a second. Just give me a second. I will give you this one here. I will do a sorting. Sort by this item here. Sorts. You enter all this number here. You have this number. Put it in there, by the way. Enter them one by one. The total score. For the last column. Is there already? Okay, good. Then in that case, you do a sorting. Sort it. You sort it so that the top will go to here. The bottom will be here. You follow me? So that's basically what you'll be doing. You sort it, and you should get it in this way. You sort it, please. Now, once you sort it, I will hold on to the total score here to do the sorting. You should get something like this. If I do a sort, now the sort is this one here. You can see that from A to Z, right? I'll sort by this one here. I will say from the largest to the smallest. Okay, sort it. Largest to the smallest. You sort it. Sort. You see that? All my top will come up here. Bottom will come up here then. So you will see that something like this. This is a P, right? Okay, and then you will see the this is a P here. And I will show you this a minute. Now the top group, hello, bottom group. You see that? That's how you can do the calculation. Clear? So you can do it. And once you can do it, you can duplicate it all the way down. Okay, and you need help anyway. It's okay. You can do it slowly. What time is it? It's a lunch, right? You let me know. No problem, okay? Good. It doesn't matter what time you put it there. 12, okay. 12 is okay. Okay. Okay? Over the size of the 10. Is it 10 here, by the way? No, I only have what? 5 only 5. 5, okay? Divided by 5, not 10. In my case, I only have 5. There'll be 5, right? The top will have 5. Same as the bottom will also have 5, right? So 5. So we're divided by 5. This is for the MCQ. Okay, got it? Good. You got it? You didn't get it? No, for MCQ, that's how you do it, right? Hello. You get number of students correctly, right? Mark correctly for the MCQ. In that case, it's how many? You must check and see, okay, for the items there. Then minus the number of correct answers from a bottom group. Then you divide it by, in this case, it's a 10, but in your spreadsheet, it's a 5. You follow me? It's 5. But each group, the size is only 5. Am I right? So it's only 5, right? Okay, yeah, just a minute. Let me just close this one here. Okay, something like that. Hey, how come? Wait. Yeah, it doesn't close. Wait a minute. I better close it. This one. Can you see? No. Okay, so that's how you do it. What's that? It's okay. Don't worry. Don't worry if you make a mistake. It's quite right. It's quite easy to change all this because you can just duplicate all the formulas, right? Across. You do it for one cell, just copy and paste to all the other groups. It's the same. That's one thing good about the spreadsheet. You copy and paste all the formulas across the whole row. Quite easy. Don't do it for each and every one. It's very time consuming, right? Just copy and paste across the whole row. Then you get all the answers. But you make sure to do the first one correct. That's important, okay? Then the cuts across will be correct. Sorry? The top first, you have to sort first. Okay, you must sort. The sort is based on the total score of the test paper. Not the total score of the MCQ, no, it's the whole test paper. With the test paper, they will have MCQ, they have short answers, everything is there. It's a whole paper. Not just MCQ. Please don't do that, okay? So sort by the total. That's why I give you the total. That's important. So you can do the sorts. You all got it? They are still struggling, some of them. What's that?
All of them are correct except for this one.
It's okay.
Is it different?
How much? No, don't worry about it, because sometimes there could be some errors here and there. Don't worry. You can go back and check into this one, okay? Yeah, not an issue there. Make sure the formula is correct. I may have changed some of the score there. That's right. You don't worry about it, yeah. You see whether that's okay right now in this size here. That's important, okay? Anyway, I just want to get a good feel how you will do it. Don't worry about the accuracy at this stage. You follow me? I think I want you to do is to look at the D here. And can you interpret what they are? That's important. Am I right? Okay? Now, if you look at this item here, it is a 1. What does that mean? Now, this item here, okay? What does that mean? 1 means what? It's a damn good, excellent, right? Really, the top score, the top scorers and those scorers, there's a big difference there. It is good, all right? So, of course, you don't see anything which is negative. If a negative, it's bad. That's one of the things there. So, now, what do you think of this one here? 0.2, for example. You think it's good or bad? Poor. It's poor. It cannot effectively distinguish these two groups, in other words. You got a feel for it now, okay? Yeah. You want to take a short break? Anyway, I get a short break, okay? All right, your mic can take a short break, about 10 minutes, I'll come back. Take a short break for the people. Getting harder and harder. It's not very simple. Okay, take a short break, come on. Let your mind rest. Yep.
Number of students in one group is for here is I've lost here.
Number of students in one group, you have the top and bottom group, right?
Yes, which is 5 and 5.
5. So just 5 lah.
So it's just 5.
With one group only, it's 5, right?
Oh, so it doesn't matter which.
It's the same size, what? Same size, right? So there's only 5 lah, in that case. Ah. 0. What? Usually we try to, as I said, so you can just round it. It's okay because it can be between good and yeah. You don't worry too much about all those little.
Let's add up at the top line. I know. Less than 0.4, is it? To get the boundary and the limit. I think this one is.
They don't. The interpretation is not so rigid about it. They're not so rigid about it because you see, if you talk about these two, excellent and good, it's very grey. Yeah, the boundary it is not as clear as what we do in By the way, this is the statistics we only do it roughly. Yeah. By the way, all these things actually come from the.
Total divided by 5.
get data from the other learning centers for the module tests, right? How do we overcome the issue of, the instruction, the teachers, the quality actually affecting the results themselves? If you have some centers where the teaching was good, the results are likely to be different from centers where the teaching was not so good, so the data would be corrupted, right?
It may be corrupted. It could be due to that. But you see, right now we only look at the test item itself. It's hard for us to judge them about what they are. We only look at the test item itself now. Okay? If you want to reflect the quality of the teaching, it's a different ball game altogether. It can be done, but the search can be a bit complex. It can be done. Yes. It can be done. It is not impossible. We have to do some,
What he's saying also is that will that affect also your test items? Because could be the test item, it's like you say, some of the not so good, like let's say this item will be the question.
That is why I say if you have a very large sample size, it will eliminate all those little issues there. You see, one thing about statistics, you have all the outliers there. Definitely it will happen no matter what it is. You try to minimize the number of outliers, having a large base. You get 100 of them. If you have a few outliers here, I don't mind at the top. I can throw them out. You follow me? So that's but right now I'm only focusing on the test item. How good is this test our order at this stage? Okay, if you want to go to the next one, I'll touch on my after the lunch. I'll touch on that one there later on. In fact, you asked me before I touch on that part there. Yes. Okay, good question. Yes. Right, okay, Andy? No, okay. Okay, good. So do a second one for the what? For the partial credits? Or?
Must find the average.
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 Average, no, it's just an average. It's everything altogether. Actually, it's the same. If you add together, it's the same thing.
It's the same thing, right?
Same thing, yes, the same thing. But usually people like to find the average, so they will know the average of the top group, average of the top middle group. But it's the same thing because you still multiply the number, so it's back to the same thing. Oh, by the way, just let you know that all these statistics are actually created not by educators. They are actually created by the psychosomatic experts, the psychologists. They create all these things because they want to measure all kinds of. You see, one thing about in psychology, there are all kinds of measurements. Okay? But the thing is that what they do in psychology can be used to measure students' performance. You follow me? That's the whole idea. So we use that one to talk about measuring, the students, measuring the test instrument. So that's what it is. Yeah. Okay, you want me to carry on? Okay, I'll carry on then. All right. Let me carry on. Where's my PowerPoint? Okay, we talk about this MCQ here just now. Now, that's what I talk about. Did I cover this one here? Okay, I did cover, but take the average score, right, on the top group, minus average score on the bottom group, all right? So you take the maximum, you will take the average of them to do that. Okay, so you take the average, remember that, okay? Then you divide it by the maximum score, which is what? Which is a 5. So the average minus the average divided by 5. You get the D here. You got it there? Okay, good. Then let me just go on. Now, you have learned the two indices. The first one is called the what? The difficulty index. And the second one, we call it what? Discrimination index, right? How to use them together? To interpret test items. All right, so now we're going to use these two indices to analyze how effective is of the test item here. Then you will decide whether or not the items need to revise or to replace or to keep for that very matter. Now, you got all these possible scenarios. The first one, look at the first scenario. You have very high difficulty index but low discrimination index. What does that mean? Now, let's say if you have a multiple choice question, 95% of students answer correctly. That means what? Your P is equal to what? 0.95. Am I right? But when it comes to differentiation index, it's 0.1. Very low. Low discrimination. What does that mean? It cannot differentiate. You see, that means what? Because it's so difficult, literally, they cannot, I'm sorry, it's a very easy item, sorry. Alright? Sorry, it's a piece, it's a very easy item here. It's close to 1, right? Because of that, it failed to discriminate the students there. Both groups can answer correctly well, equally well. You see that? So because of that, that item have this. Now what can you say that? The test item is too easy, number one, and does not differentiate between the high and the low performing students. It cannot differentiate that. It's so easy. Everybody can answer it correctly. So what do? You got to rewrite the item to include a more challenging. You have to rewrite it. Make it a bit more challenging. So this is a bad scenario, by the way. You see that? When you come up with something like this. Now that's how you use these two indices together to interpret the effectiveness of the test item. Number 2, you have very low difficulty index, but you have a negative discrimination index. Now, let's say I take a physics question. Can only answer correctly by 10% of the students there. Okay? So that means what? The difficulty index is 0.1. Very difficult. Fair enough? It's a very difficult question. Okay? And how about the discrimination index? Negative discrimination. That means what? The low performance group gets better than the high performance group. Fair enough. They're just guessing, right? Guess, I'm going to get it right? So in other words, the item is too difficult and the weak students are guessing correctly more often than the stronger students. What's the cause of it? Likely to be what? Confusion in the question there or misleading wording. Because top students tend to be very careful about what they read. But because you make it so confusing for them to read, they know what they are reading, so they answer incorrectly. So that's how it happens. So that's why, if that were the case, review the item for ambiguity. It's too ambiguous already, or even got errors. What can you do? Maybe just simplify the language or break the question into 2 parts, part A and part B. You follow me? So that's how you would do it. So this index do give you something about the test items. That's important. Now, one thing about psychosymmetric measurements, the interpretation can vary somewhat. It's not really as precise as what we do in mathematics. Even though these are statistical tools, yes. But when it comes to interpretation, it's just subject to many other factors. Don't forget, numbers cannot tell you everything in life. So that's why you need to look at the facts affecting it. Students may be weak in doing that because of the environment. Either it's too hot or too cold during the exam hall there, for example, affect them also, okay? So these are the kind of a thing that will affect the students there. So there are lots of other, it's an environment or what they're doing it, there's a construction outside, very noisy, affect the exam hall here. So these are the external factors. Now, if you have this external factor coming in there, all these statistics cannot tell these external factors. Am I right? So that's the reason you have to take into another factor, which is what? The human consideration there. It's always the case. So don't take this as it's a hard and fast rule. No, it is not. But I give you an idea what it is. You see, one thing about statistics, look at what is a trend, how the thing looks like, roughly how it looks like. But there are exceptions in this case here. All right, so so that's basically what it is. Yeah. There's one. In fact, we're talking about statistics. There's a quite interesting history about statistics. Now we put statistics in mathematics, right? In the good old days, statistics had never been considered part of mathematics. Because mathematics look at it, they say it's very imprecise, which is true. They are not very precise. So that's the whole idea, We kind of come to the intuition of the statistics there. It can vary here and there. Unlike mathematics, 1 plus 1 must be 2, cannot be any other answer, for example. It's so precise. But this one is there's a bit of gray area. It's estimate roughly, that's where it is. So since it's about roughly estimation, I estimate roughly that it is. So don't take this number as it's absolute. It's not absolute. If the answer turned out to be a negative 0.25 or 0.1 for that matter, it's still bad. I don't care whether it's 0.25 or 0.1. Am I right? That means my low group is still perform better than the high group. Put it this way, as simple as that. So you see, that's only a rough indication of what that is. Now, the third scenario. This is a math question, answered correctly by 60% of the students there. So, what's the difficulty index? 0.6. Okay. It's a moderate difficult. It's good. It's a moderate range. Not extreme, It's a moderate range. Okay, so you're moderate difficult. And how about the difficulty index? 0.5. Excellent. You need that. As long as bigger than 0.4, because that's good, right? So we'll do that. So in that case, this question is performing well as it is moderate difficult and able to distinguish between the top and the bottom groups effectively. So keep these good items, don't throw away, or use it as a model for writing similar questions. Oh, it's a good one. I keep it, but I want to change for another year. I change the context, anything, but something similar for the next year students. So that's how you collect all the good items. You see that? So that's one way of doing it. The fourth scenario. %60% of students get it right. So your P is 0.6. Okay? It's a moderate difficult. But how about the D? Well, very poor. Low discrimination. What does that mean? That means it cannot really distinguish the top and the bottom performance, right? So that is what it means. It failed to distinguish between the top and the bottom performance. So in that case, you review whether all the options are plausible now. I'm talking about MCQ here, by the way. This is MCQ question here. Okay? Because your distractor may not be effective. That's the reason why. It can happen. So, okay, you may add distractors. There are more that specifically challenge the misconception among the low performers. I think I did talk about how to set MCQ questions there, about the distractors there. Okay, usually they will talk about the misconception made by students here, for example. So these are kind of the thing you have to bear that in mind. All right? Okay, so now give me your feedback so far. You have learned these two indices for the analysis. What do you think? Do you think it's useful that you can use it? Or you think that, not so useful? Or you think that, whatever issue that you may have? Come on, just share with me. Any feedback on these two? These two are very basic, but these are two are very basic item analysis statistics. We shall come to the more advanced one later on. I will show you. Okay, what do you think? At the back there, ladies, you think you want to use it, or you don't want to use it? What do you think? The front one, gentlemen, get to have it.
Sample size, the students top performers it's not even in the 90s, let's say top performers are in the 70s.
What are the top?
The top performers do you still pick the top performers? Let's say their highest scores among the sample size that you have, let's say 70%.
No, you have to sort it out by the top.
Yeah, so the top, after you sorted everything out, then your top.
You cut out at 27%, cut off, so it will cut off already.
So the 70% is not even the top.
No, okay. That's a good, let me mark it here. You have your students all here. This is the bottom, right? And you're the top. Hello? Middle, 100%? 56? 46? Am I right? That means exclude. That means these are the one in the middle. We only look at the top 27. You cut off the point there. No. It's a total score. Let us say the total score here is, let's say you got 90 to 80, for example. Just say that. But let's say up to here, someone is doing 80 down here, right? You only cut up to here only. You leave out that one. The top only. You don't take the 70%, by the way.
What I'm saying is the total score is based on the marks
of the whole test paper.
Yeah, the whole test paper.
Ah.
So out of the whole test paper, let's say the students, which is actually normal for school, very few will hit above 90%.
No.
For the total marks.
The marks.
The percentage.
So the 27, the top 27%,
Yeah,
let's say it's 5 students, right?
Ah.
The top one is not 90, it's only 70.
It doesn't matter, no. It doesn't matter. No, okay. This one can change.
Yeah, so it doesn't matter.
Doesn't matter. Don't worry about that. It can, I see what you mean. It can be, I'm just using, okay, it can be, okay. Let's say you can even have this one here to be, let's say, about 75 to, let's say, 62, for example. And the bottom can be, maybe it's about, let's say, the bottom can be about 30 to maybe 0, whatever that is, let's say. That's okay. You don't worry about that. What you do is you sort out, you chop off 25 to 27%. That's what it counts. You only base on the total score to cut off, regardless of what that is.
But will that also indicate something?
The only thing it will indicate is this. Difficulty index. That's the only thing. You see, that's the reason why you need these two indices. You need, that's what I will show you, because you see, we need to have this combination of the two indices there. Am I right? You need these two. You don't need to be too difficult and too low DI. Correct or not? So you want to have the P and the, you have to, that's what I say. You have to really learn how to balance the P and the D, these two. That's important though. The purpose of showing this fourth scenario is to learn how to use these two indices, effectively to when you analyze the test item. That's all it says. If you have something like this, by the way, it's considered what? It's a moderate difficult in a way. If majority score very high, but above 80, that means it's relatively easy test item. Am I right to say that? But if it's very low, let's say, maximum is only about 50 out of 100. Oh, talking about that, I've seen in my university, one time there was a chemistry test. The top mark, 50 out of 100. The bottom can be quite low. Okay? And only 2 questions. Long question, 2 questions. Each question is a 50 marks. Given by the professors, okay? It's a chemistry. Okay, I was in this class there, and I score about 40 plus. Oh, very bad, And one thing is about, it's an open book. Bring your book, anything you want. Any form you want to bring it in to your classroom there. Up to you. You can refer to it. Only 2 questions. Because you know why? The professor also quite democratic. He asked us, okay, next week we will have a chemistry test. Oh, okay, good. Oh, okay, what do you want? Closed book? Open book? Everyone, open book, all right? Okay, open book. Next week, open book, right? Open book. Maximum is only 50. Yeah? Most of them just fail. They can answer 2 questions. I only partial for the first one, partial for the second one. By the way, that is a chemistry on the what? On the thermodynamics. It's a killer course. That one's a killer course. Okay, using lots of partial differential equations there. So anyway, so after that, finally, next one, so say, close book, no more open, close. But seriously speaking, so in other words, you have to look at the difficulty index. That's quite important. I agree. You see, you want the item to be good enough to be moderately challenging, not difficult, but moderately challenging. At the same time, you can also discriminate the top and the bottom performance. Now, that's an ideal test item. It takes time to construct such an item there. Fair enough? I don't care whether you're doing in science, in math, or language, doesn't matter. Excuse me. But anyway, don't worry. I think when you first use it, you may find it difficult to interpret the results there slowly. But once you have the hang of it, it will be a lot faster if you can do it that way. Okay? So far, you have learned you have learned 2 indices. Now, there's one more, okay? So we have seen how to evaluate the level of difficulty. You have learned how to evaluate the power of discrimination. Am I right? Now we come to the third one. How to evaluate distractors. Distractor analysis. Now, this is about MCQ, yes. And of course, later on, after lunch, then we'll come back to this one here. This will be the last part, okay? Talk about the content validity and the reliability. Now, remember just now when we look at the difficulty index, what are we looking at? We look at the number of correct responses. Am I right to say that? Correct one, okay. But now, instead of looking at the correct responses, we look at what? All the incorrect responses. These are the distractors, right? You're supposed to see the purpose. What's the purpose of distractor for the MCQ? See how effective they are. That it can what? Draws it away from the correct answer. That is the purpose of distractors, to be able to distract them from the right answers. If you have such a good distractor in your MCQ, it will actually, talk about, make it effective. So in other words, we talk about the effectiveness of the distractors It's basically you contribute to what? The quality of the test items. It strengthens the quality of the test items. Because if we don't have a good distractors, sometimes you're literally giving away answers in MCQ very easily. Especially for language, MCQ. If your STEM has something, had these two words there, I'm sure the kids can guess their way very well. Why must you put and N together at the same time? You tell me. They can guess easily. So don't do that. You give away the answers. In other words. Say? Or if you have, answers, but one option is very, very long, or one very short, it's very long. You're giving a hint to the kids, am I right? So these are kind of a thing, whether your distractor is effective or not effective. Now, how do you have good effective? Usually you make use of the what? Students' misconception. It's very well. Okay? For example, I give you in mathematics. Kids always, they will always see the square root of what? A plus B is equal to what? Square root A plus square root B. Am I right? Common mistake. Now, these are the good distractors here. I give it to the kids. That's one of the distractors in my MCQ. You see that? So these are the kind of thing that you can do it. I will show some example here later on, how to make a good distractor. But you see, if you have a good one, that means what? It can really tell you the quality of the test items. Now listen. Distractor analysis can also be used what? To differentiate high and low performing students. Same as the difficulty index, the same. You can also differentiate them, right? The high performers and the low performers. Now we look at the distractors. Not the correct answer, but the wrong answer, so to speak. All right? Now let's how to look at it. Now, we got these two terms here. Functional and non-functional distractors. What's a functional distractor? It's a one that attract what? 5% or more students. That's considered as a good distractor. Otherwise, it's non-functional. It's not very good, in other words, okay? Now, by the way, when I have that one there, I must say, you must have at least 100 responses, 100 students to use the 5%. But I don't have 100 students. What can I do? So I give you a very rough suggested threshold of the functional distractors. If you got less than 10, at least 30% is a 5% per distractor. MCQ, usually got 1 correct answers and 3 distractors, right? I'm talking about each one of them must be at least 30%. Not only one, or each one of them must be 30%. These are per distractor for each distractor, in other words. If you have about 10 to 19 students there, okay, this can be lower. It can be around 15 to 20% per distractor, roughly around there. You got about 20, 29, it can be even lower, 10 to 15%. But you can minimum 30%, then yes, you can use standard 5%. Anything beyond that, 5% is good enough. Per distractor, this is important, per distractor. So now in this case, what we do is that for each test items, we look at each and every distractor. A lot more work here, yes. Unlike the difficulty index, only look at correct answers, right? Only one, right? But this one, you got 3. Each one you got 3 times. Okay, now. Oh, by the way, there's one thing about distractors. Let's say you have an MCQ got A, B, C, D, 4 choices. One is a key, which is the correct answer. 3 are incorrect answers, fair enough. These 3 must work together. If you have 2 are good distractors, but one are no good. What does that mean? You give away also in a way. I mean, you think about that. If two are no good, one is very good, useless. He will know which one to pick. So in other words, you try to make it in such a way that, all the three of them are functional distractors. That's why I keep saying that it must be per distractor. For each distractor that you have to make sure that it's equally functional. Not only one, all three must be equally functional. Now, this is only a suggested threshold. These are not stone casts, to be quite honest. If you go for another talk on this number may change. These are not fixed. In fact, when you go back to your students there, you look at your sample size, how many of them, you may even want to vary this slightly somehow, up to you. Usually it's about this range. You follow me? Somebody say, no, I want to look into about, maybe about 14% or 20%. It's still fine. There's some variation here. So don't take this as a stone cast. It must be like that. But however, I can say one thing safely. If you have anything at least minimum 30 and beyond, the 5% is very safe. Lower than that, that means your distractor, it's hard to tell whether or not they are functional, to be quite honest. That's the reason why we be more stringent in terms of percent. We're high to make sure that these are really effective distractors there. Follow me? Okay. Now, there are many methods that people use to evaluate distractors because they will look at it from different perspectives. That's important. For example, look at it from the sample size of responses, how many of them, and which method is more suitable for use then. I recommend these two first. I don't worry about the others. There are many others, only these two. The first one is called the response frequency analysis, quite similar to your difficulty index. The second one is called the distractor discrimination index. I'll cover these two here, okay? One after another. Is there time? Okay, good. Now, let me look at the first method. It's called the response frequency analysis. Let's say I have about 30 students. Okay? Now, this method provides a rough estimate. By the way, one thing must say, it's only a rough estimate. No? It's not exact, it's a rough estimate. And of course, I say, the larger the sample, the more reliable is the response distribution. Fair enough. Larger the better. Now, here's the formula. It's quite easy. Not now. The DI refers to the particular distractor. Don't forget I have three, right? Look at all the three, one by one. So I will call it DI. So it's a DI1 is what? DI1 is the first distractor, DI2 is second distractor, DI3 is the third distractor. Okay, I got three. Look at them individually. So look at how many students select that particular distractor. Let's say that you have an MCQ. Let's say you got A, B, C, D. Now let's say your key is here. How about your key is here? Okay, this is a correct answer, right? Correct answers. Now, these three must be distractors, right? So this can be my first one is my D1. This is my D2. This is my D3. You follow me? And I'm going to do it separately, one by one. So I'll take one, okay? So let's say I will take, see how many students will choose option A for the very matter. So, divided by the number of students. So 100%. And that's how you do it. It's quite a simple way of doing it, okay? Now, if you have anything less than a small sample there, my advice that get some subject matter expert view to look at it. Because if you cannot tell whether or not that's a good distractor, get some expert view, okay, to look at it, to determine whether they're simply too obvious or unrealistic. Look at it. And if that's the case, you have to reword the weak distractors to make them more plausible. So that's the whole reason why we need some expert view. Human intervention, not just the statistics as such. Okay, look at this science MCQ here. Why do plants need nitrate ions? Chemistry, or bio rather. It can be chemistry, it can be bio. It all depends on where it comes up from, okay? Because there's something called a biochemistry. So people they can use it. Now, and if you look at, these are only the 4 compounds: fatty acids, glucose, amino acids, and starch. And the only thing that had to use the nitrate is only amino acids. So how the kids must remember all the formulas there, fair enough. Each one have their own formula there, okay? And they will see that in all the formula there, the letter N, which is for the, what's that? Nitrogen, am I right? Will never be found in any of these 3 compounds except amino acids. So that's the correct key. Now, okay, now you give this question to the kids, and they'll start choosing, okay? Now that's what I have. So 3 students choose A, 5 choose B, 15 choose C. So C is the correct answer. Fair enough, is a key. And 7 choose D. Now, so what I'm looking at, I don't bother with this one, I'm looking at this 3. So I will do my calculation. Now, assuming I got 30 students here. So I can use 5% as a cutoff point. So you see that I will do it. Right? 6 of them, correct, choose A over 30. Since the class, the size is 30. So work it out there, 20%. Oh, it seems to be quite effective function. No, fair enough. I can say that. And same for this one here, okay? Now this one, yes, you can do it, but this one basically tells you what, by the way? What does that tell you, 50%? This is called the what? We have just learned it. Yeah, difficulty index, correct. Okay, the difficulty index, correct. Expressed in the percentage, yes. So this one basically refers to the difficulty index. Now these are the ones that distract the students there, right? How many percent get it? Choose A. 100% choose B, for example. So these are basically that you can see, how this. Now the D would be, by the way, it's only 3.3%. That means what? It's a lousy distractor. So you need to replace it or to modify it, whatever that is. You see that? So that's how it's being done. Fair enough? So now every test items, you have to calculate at least these 3 distractors in this case. Okay, where's the time now? That time? Okay, now you can do this one first, okay? You have this spreadsheet here. You got what? 15 students and 5 MCQ questions. That's how they will choose it. You can use a count if though, by the way. Count if. It's easy to do the tabulation. Now you know how you use the count if, I show you. Of course you can do it manually if you want to, by the way, but if it's a lot sooner, it's a lot very time consuming, right? Use the count if. Okay, let me just write out clearly. I'll write out here. Where's my eraser? My eraser is here. I'll show you what it means. I'll take this one here. Okay. I put out what? Count if. Brackets. I will have a range B2 to B16. comma. Now, look at it. What does that mean? I'm looking at question 1. Am I right? Question 1, you got A, B, C, D. Fair enough. I know that the key is what? Is B. Answer is B. So A, of course, is a distractor. Correct? I will pick out this question number 1. Among all the students here, how many of them have chose A? Chose A, right? They've done A. So I do that. From row 2 to row 16, that means what? B2 to B16. How many of them choose A? I put an A here. This is my condition. You follow me? And once you do that, and on this cell here, you park, you say 3 altogether. You can count. Same thing. Over here, I simply need to change 1 to what? To B. You follow me? And it will give me my 6. You agree? Then it's the same thing. So 1 by 1. Now, of course, C is a key, by the way, so I don't worry about it. I go to 2 and the 4. I can see that. How many of them? And the important thing is that I will calculate all the 4 of them, by the way, A, B, C, D, including the key also. Why? I want to see whether or not I get 15. That's important though. You see that? This 15 is what? It's a sum of these 4 items here, including the key, by the way. Make sure that I got the correct total responses. 15. And you do that for each and every cell here. Question number 2, same thing here. Okay? So you can do the same, in other words. So in that case, for question 2, you simply change what? C, right? C to you follow me? C2 to C16 is for question 2. Question 2 is from C, column C. So you will do that. Slowly, come on, just do it. Help one another, you are not sure. By the way, do copy and paste a lot faster. Just change the condition. That's it. I give you time to do it slowly. Never mind, don't worry. Okay, I think we'll finish up this one, then we'll go for lunch. Now, after they've done that, how to calculate the distractor index here? What do you do? Let's say for question number 1. Option, what's that? Option A, okay? Option A. How many students choose option A? Number of students? You have 3, right? Okay? So how do you find? Back to my... How do you find the P of my DI is the first one, it's my A, right? My answer A is what? It's 3 out of what? 15 times 100%. You follow me? So that will be the answer that you have. You follow me? So that's how you do it. And you do it for each one of them, for the distractors there. That's how you do it. Follow me? So once you have that, then you will have, let me get back my spreadsheet. Okay, so the next one, well, P of A is what? No, P of B is correct. No, P of C, the third option there, the third option is what? Is 2 out of 15, am I right? Times 100. The last one is D, 4 out of 15. Who can give me the answer for all the... What's the answer for this one? Come on, who can tell me? 20%. This one? This one? Okay, good or bad? Now look at the criteria there. Good. Is it good or bad distractors? Is it functional? C is non-functional. You sure C is not functional? I got how many students here? 15 students. Okay. So 15 students, usually I will take what? 20, right? So this is no good, right? Yeah, right. This is still okay. This is no good. See that? That's how you do it. This is a rough guide for you to see how you do it then. And you do it for each and every test items. You got it all out, by the way? Yeah, come on, just get it done, all the 3 of them. You can save it, by the way, save your spreadsheet then you won't lose the formula. Then you will lose the formula there. I didn't complete here. You can, by the way, you're free to put it down here, okay? All this, P of A, P of B, so they can put it down here. Up to you. Your spreadsheet can do all the calculation there. You don't need to do it manually, okay? It doesn't share with you. Okay. Let me touch on this one now. Let me go on to this one here first now. Just a minute. I will put it on to this one. Now, we are going to use the distractor index to distinguish the high achievers and the low achievers. It's the same, we still take the 27% as the cutoff line when you have 100 students as such. Okay? Now, instead of looking at the high and low achievers or the correct answers, we look at them, how they choose each distractor. That's what we are doing now, okay? Now, same thing, a good distractor should be able to what? To distinguish them. That means what? It will be chosen more by the low achievers, more frequent than the high achiever, in other words. That's a good distractor. And the way to calculate is this one here. Number of low achievers minus the number of high achievers. This is the other way around, okay? Watch out, I do it the other way around. Divided by the total number of low achievers. By the way, high and low doesn't matter. Why? It's the same number. You see that? Same number. So I don't worry about that, whether high or low. The total number of low achievers in one group, that's basically what I'm talking about. And you can find this, what we call the Distractor Discrimination Index, DDI. Now, give one example, the language. You have this one for the kids, for students here for language. Okay? The champion, this is a fill in the blank, okay? The champion, dash, okay? to the strength of the opponents. I got 4 options here. Give on, give up, give back, give in. So, which is the correct answers? Of course, I put a key there. Okay, so the D is the correct answers, but A, B, C are all distractors. Now, let's see how they would choose it. So, they go to this one here. Then you see that this is how they would choose it. Okay, so 2 from the top group, 10 from the bottom group, so on and so forth. See, that's what we have. So that's the table. Now, after you capture this data, then you do the analysis. Now, I'll just take one of them, okay? This one here. Let's say the A. The bottom have 10, right? They choose A. The top group, only 2. Okay? Yeah. And since I have 100 of them, so my top group is about 27 of them, by the way. So 27, so I will do the calculation here. Same thing. So it's a what? It's the bottom group. How many choose the A minus number of top group choosing A divided by 27. And so therefore, it's a good distractor. You see that? So that's basically what it is. Now, with this one here, you get 0, right? You cannot distinguish the two. Both top and the bottom group choose the same, in other words. Equal number of students choose the same. And this one is the worst. Okay? It's a bad distractor. Why? It seems that they're less choosing the C, but the goods, but the top achievers, they have 8 of them. So it's just the other way around. So these are kind of things you give an indicator. This is a bad distractor. So in that case, I may have to do some revision on these 2 distractors here. I can keep this one, yes, but I have to do something about this too to make it more effective. It's a very straightforward calculation here. But of course, here my size is 100 students, by the way. This is my sample size. Now, so basically you have these 3 groups here. Okay, in other words, you got anything from 0.1 to 1 is considered as effective distractors. What does that mean? That means what? It's highly effective. This is a very good distractor there, okay? And they choose significantly more often by the low performers than the high performers. So you retain this distractor. It's a good one. But where you should have something like this, negative 0.1 to 0.1 is considered a weak distractor. That means it's not so effectively to differentiate what? The low performers from the high performers. So, slightly negative success for one thing, what? It means that this distractor may be misleading to the high achievers. So, you may need to revise it. So that's the meaning of it there, okay? But if everything is so negative about it, I don't care whether it's a -1 or it's a minus 0.1, it's considered bad. That means you totally had to what? Revise or replace. Which totally is not effective at all. You see that? So that's how you look at the distractors there. Now, I think I've covered this previously in the last slide. Just refresh your memory. What are considered effective distractors? Well, all the possible distractors, as I said, use the what? The misconception. There's one area there. Okay? Keep the length of source about the same length. Don't keep, as I said before, one short, one long. Don't do that. About the same length. That's the whole idea. Now, these are the few words. Try to avoid. It's very vague. Always, sometimes, often. Now, by the way, this word can only be used when a test of the language usage. Yes, language is possible. You choose which is correct word to use. It's okay, but not for science and not for math. I disagree. Okay, It's very bad word. Always, not always. Sometimes, often, hard to tell. So it's very vague. These are very vague words that we use, okay? I know that some people love all these things, all of the above and not above. I will try to describe the use of these two. However, if you want to use it judiciously. Be careful about it. Okay? If you know how to use it carefully, try to avoid it. Please do. And of course, you make sure that, your stem and response options must be grammatically correct. That's important. You write a sentence, to get the stem and the options there, everything must be language, must be correct. So there's a very rough guideline for writing effective distractors. By the way, it takes time to construct, to be honest with you. I experienced it myself. It's not easy. Because sometimes we are not careful, we give away the answers easily. Unknowingly, you give away the answers. You don't know that. Oh, I get answers. I didn't even know that. It's quite possible. Okay? So, yeah. Okay, I won't go into this one now. I want to take a break now for the lunch. Okay? All right, I think that, yeah. I don't know whether I have an exercise for you on this one. By the way, I don't think I have exercise on this one here, the DTI, but you can try. It's not difficult, by the way. It's the same as what you have done earlier on then. Okay, for the DTI. All right, let's go for the lunch, and then we'll come back. I will finish up. Okay, hopefully I can finish up a bit earlier today. All right, good. Now, this is the last part now. I think I should finish it probably slightly after 3, before 4. I should finish the whole thing. Now, so far you have understand this item analysis. This is the micro view to evaluate the test effectiveness, because you're actually looking at the individual test item. That's one of the things there. Okay? Yeah. But now we'll take a global view, or the macro view, so to speak, of the whole test paper. And that is where we look at, remember, talk about validity and the reliability. Now, these two, basically, we're looking at the whole test, not just about individual test items, but the whole test itself. So let's take a look at this one here, okay? And the first one, talk about the validity. Now, as I said, what's validity of a test? It refers to what? The test, whether the test measures what's intended to measure. That's important. If it doesn't measure what it's intended to measure, it defeats the whole purpose. In other words, you must what? Stick to the learning objectives, the whole thing. Remember that. Don't go beyond the learning objectives, okay? Now, we have these 4 types of validities. Now, I have no time to cover all the 4 types, to be honest with you, okay? So today I only cover one type, which is the most relevant, as far as you are concerned, the content. Okay? Next time I'll talk about the other 3. Not this 3, I don't think you'll be using it, but these 2 probably still be useful for accuracy here. Now, this one is a bit, if you want to do this one here, you may have to bring back, maybe the IG kind of a so-called their test there to look at, to correlate with the so-called the school test score here. But we won't do that one there. Okay, fair enough. So we won't do this one here, but only today we'll do the content validity. Now, the content validity, I will propose something very simple here. In other words, we want the content to what? To cover all aspects of the construct it is supposed to measure. Okay, now, what we do is that we will look at the what? Expert review. That's important. So when does something, get an expert look at it? Okay, by the way, what do you think? Does it cover, all the aspects that we want to do then, to ensure that they are relevant and they are comprehensive? And also it must align, as I say, with the learning objectives, the last but not least. Now, in terms of the content coverage, ensure that all the test includes the representative sample of the content domain. Not only a certain domain, but preferably spread out, cover most of the content domain. Of course, some domain you may do more, some may be less. It's okay. But as long as you cover them all, proportionally. So that's the whole idea about the content validity here. Now, so if you do all these things, I think you are quite safe. I think usually in your case here, it's not so bad because you have your IG syllabus and you're very much guided by what, because I believe IG, they do have learning objectives, by the way, they're very good. They have assessment, so you stick to it, chances are you will not be wrong. The only thing that you may go wrong is about the quality of each individual test item. That's where you may make mistakes here and there. But other than that, it's fine. Okay? I don't think you will go overbound. So I don't need to talk so much about that one there. But you bear in mind, you are not just talking about covering the content alone. Actually, we'll talk about the construct, the concept of it. What are the concepts? What are the skills? Now, these are the things here. You bear that in mind also. All right. Now, reliability talks about what? Whether or not the test is consistent in measuring what's there to measure. It must be consistent, in other words. If it's not consistent there, that means the test is not reliable. So the question, how do we evaluate reliability of the tests? Huh? Yeah, pre-test. We have what we call the test and retests. Okay, test and retest is one of them. And there are different types of methods that we use here. Okay, there are many methods, but I only cover these three for today. I cannot cover too many, since it's only 5-6 hours. Unless you do a full 30 hours, then that's a different story. I'll talk about the test and retest reliability, the split half reliability, and the inter-rater reliability. So these are the three I will cover for today. What's the test and retest? This one basically is talking about how consistent the test is over a period of time. That means you are going to administer 2 tests. All right? So let's say a test administered to the students. But the second test is about the same time as the first test. That's important, okay? And you also administer to the same group of students after a period of time. Now, what's important also, that could be an environmental factor. You make sure they're also done in the same environment. Don't go to an environment where there are some disturbances here and there or whatever that is, then it may affect the reliability of the test, okay? And one thing about these 2 tests must be quite equivalent. It cannot be one, the first test, second is a bit harder or easier. No, same. That's how it is being done, all right? So you say that for the administration of the second test, okay, for the test maintains the same format. You got so many MCQ here, same for the other side. Short answer, same, okay? Same format, same level of difficulty. Not to be harder or easier, same level of difficulty, except what? Different wording, different context. You change the context, change the wording, and see how they perform. Maybe after 1 week or 2 weeks, okay? Of course, not after half a year. That means it's very long, but it can be as long as about 1 month. Some of them try for one month, test and retest. So that's basically what it is. Now, I'll give you some example here later. Now, so let's look at the science. Let's say I have a question. In the first test, I have this question here. Okay. A light bulb is powered by electricity and produces light and heat. Describe the energy transformation that occurs in this process. The science. So first test, I have this question there. Now, how about the retest? I change to something else. Instead of a light bulb, say a solar panel. You see that? A solar panel absorbs sunlight and converts it into electricity. Describe, same thing, energy transformation that occurs in this process. I change the whole context. It's the same level of difficulty. See whether they can answer this question effectively. If they can do it almost the same, that means this test item is very good. But if you do very well for the first one and do better the second one, it's not quite right. You see that? So in other words, it must be the same. Of course, there could be differences in the marks. Let's say if this is a 5 marks, the second one is a 4 marks, it's still quite okay. I wouldn't say the marks may actually the same, but I mean it should be quite comparable, quite reasonable to close to each other, in other words. So that's a kind of a question. Now for language, fill in the blank. She dash go to the store yesterday. So you get go, goes, went, gone, for example. The first test. Second test, something quite similar. They dash a movie last night. 4 choices here. Again, same thing. So you vary the context, change the word, change the wording. So that's what I'm talking about. Now, you can see how the 2 tests are being set. All right. Any questions so far? Quite easy, yeah? Okay. It is not difficult. Yeah. Now, how to evaluate? That's where, again, the statistics will come in. All right. Now, you got 2 tests, right? So that means each student have 2 scores. The score for test 1, the score for test 2. And you want to find the correlation of these 2. So, of course, in statistics, we learn there are ways to find correlation. And the only thing that we are using the Pearson product moment correlation coefficient, by the way. This is the most commonly used correlation method that people use. There are many other methods. I won't say that there's none. I have. But I thought I'd just stick to one. Now, don't worry about this formula here. Okay? You don't need to memorize this formula. You don't need to know all the little details about what that is. Because now, thanks to the spreadsheet, they give it to you FOC. You just use it. And it's called Pearson, right? So what you have to do, look at the spreadsheet, say, Pearson. They give it to Pearson straight away. That's not easier. Am I right? Rather than to do all this. Last time in my good old days, we're going to figure out those are XY, those XI, YI there, and all the little things there, those summation, division, and all the things there. But now, no need. Okay. Now, again, ideally, it's good to have at least about 30 pairs of data, to ensure the reliability of the Pearson coefficient. Usually, as I said, statistics, it's good to have, lots of data. Okay, now, don't worry about the ugly formula there. Now, the whole thing is little r, right? Now, this is called the correlation coefficient. It's a number. Now, you get some number there. What does that mean? That's important. You must be able to interpret that number r. Am I right? Okay, so I give you the interpretation. Now, in other words, you want the r to be as high as possible. If it is a 0.9, you get excellent reliability. That means it's what? These 2 tests are highly consistent. It's good. That means your first test paper is a very good, reliable test. It does give you, a quite reliable test. Is it between 0.8 to 0.89? Considered good, acceptable. Okay, but anything less than that, between 0.7 to 0.79, is only adequate, and the test may be accepted. Just manage, so-called, make it, that's about all then. But lower than that line becomes questionable. So in other words, the test may not be stable over a period of time. That's bad. That's why when you write the second test for the retest, it's very important to make sure that the second test that you design must be equivalent to the first test in terms of level of difficulty and the format. Make sure they're the same, and that is okay. Don't change the format. Okay? Don't have suddenly no MCQ or essay or fill in the blank. Don't do that. It must be the same, in other words. So that's basically what you need to know. So this is how you interpret based on the correlation coefficient here. Now, here I got 20 students there, okay? That's only an example. I use 20 because I can fill all the 30. There are too many students to fill up here. Now let's say that I give a test and a retest. My test 1 and my test 2. All right? Now, so therefore, these students, we have 2 scores, am I right? So they take the 2 tests, and I will tabulate all the score here. I got 20 students here, fair enough, okay? So I will tabulate all the scores here. Now, I'm going to find how these 2 sets of tests are correlated to each other. I'll use a Pearson correlation coefficient. Now, how to do it? Here's the formula. It's called a Pearson This is a built-in function, by the way. Look at it first, okay? You see, from B2 to B21, what does that mean? That means I'm taking, this is the first test. This is the first test. This is the second test, right? Because second test is from here to column C. Or this is the second test. From here to here, this is the first test. Am I right? So I will take all the columns here, okay? So I have the first column, which is the first test. I try to correlate using Pearson with the second column, which is from C2 to C21. Yeah, this is row 21, right? So I say this is row 2, this is row 21. So from 2 to 21, you see that? And you would do it. And then you work the answer. If it turn out to be 0.88, is considered as this is a good test, retest reliability. That's how you do it. Very straightforward. It's not something, so that you don't memorize a complex formula. All right, so now you do it. I think you have one. Now I give you 30 students. Can you weigh out these 30 students about whether or not this test, retest, will have has a good reliability? Which we're quite the same, right? Same as this one here. You call up your Pearson. Your Pearson, you got it? Is it 0.72? Okay, good. It's very easy. Yeah? You don't have to know the complex formula. You look at it. So you tell yourself, is it a good test or not? So you have to decide on this question here at the end of the day. The figure is meaningless, right? Unless you can interpret what it says. And this one now, this is called the whole test already. This is a whole test, huh? Not about any particular test item, but whole test. Look at the whole test. So this is called the whole test reliability, not about just a test item alone. Fair enough? Quite simple, this one. Any questions so far? Okay, we have got it, huh?
Cronbach alpha for the exam.
Sorry, the what?
Cronbach alpha. We also have Cronbach alpha method.
No. Cronbach alpha, I know Cronbach alpha, yes.
The SPSS only.
I know that they have that. Pearson, they also have it. Okay? Yeah. But that one is used for another different purposes. It's for what we call for the internal consistency. So it's a different kind of thing altogether. Yes, I know that she brought up the Cronbach alpha. This is another test statistics, but I'm not using it here. Because if I were to go into this area, this is one tend to be a bit, tend to be a bit complicated. Not so much of the calculation, because now you can do it using the spreadsheet or using the SPSS, for example. But the trouble is with this test here, it only evaluates a single construct. That's all it takes. A single construct, that's where the problem is. Because in the test paper, you used to access it in different constructs. Not just one, but many. So if that were the case, you have to do the alpha, Cronbach alpha, for each one of them differently. That is where the whole problem is. Because the whole issue is that this one is to evaluate what we call the internal consistency. I will touch on this one very briefly later on in some of my slides. But the reason why I didn't go into this one, because I'm not going to go to a large extent on this whole issue here. Because I go this issue here, probably have to stay until about 6. I try not to do it. Maybe next time you want to do it, I can show you how to do that one, okay? But not for this time round. Yeah, this is I purposely stay away from it for the meantime. I know this one very well, yes. It's very useful. Okay? Yes. And if you want to combine all the constructs together in one big alpha, that's called the stratified Cronbach alpha is more complex than anything else. I try not to go into that area there. Okay, so, yeah. In fact, this one I'm making it very simple for you people because of this time constraint. I cannot go very far over this matter. Okay. Yep.
So, like, the test and retest reliability. If we test the first test, like second test, we check the reliability against the first one.
No, it's the reliability of the first test.
We use the second test result together with the first one to test the reliability
Of the first test. How reliable is the first test, in other words? Okay, when you give a test to students, how reliable is this test over time? Am I right to say that? You don't know. I'm using the second test to establish whether or not my first test is reliable over time. I'm right to say that. So I'm constructing a second test, which looks quite similar to the first test. So it's not the same, quite similar to the first test. And I test it again one more time after maybe 1 or 2 weeks, whatever that is. If the two tests come out to be highly correlated, the scores are about the same. That means, oh, my first paper actually is a fairly good, has a very high reliability here over time, in other words. I'm using the second test as a tool to establish the reliability of my first test. You follow me? That's the whole idea about doing it. Because I set the test, I must know how good is my test, right? How reliable is my test, right? So I'm using it. It's like a tool to measure how good it is. This one. It's like take the second test as a tool to measure the reliability of my original test, in other words.
Right now, I can only see the second test as how well you are able, how close.
Yeah, correct. So, yeah. No, actually they are the same because they are about the same. But the objective basically look at the first test. This is the second test. In other words, if the second test is as good as the first test, both test papers are equally good, to be quite honest. Because they means they're highly correlated. Am I right? So they're equally good, in other words. Serious. That means you do set a good test script that can be used over time. That's what I'm trying to say that. Huh? Of course, you can do a third one if you want to, by the way. I mean,
The third one we have to compare with the first one only or compare with the 1, 2, 3?
if you want to, no, listen. If correlation can only be correlated 2 tests, you can have 3. There will be no 3 test correlation. That is important. Okay? Unless you want to, okay, you said, okay, unless you want to correlate the third test with the first test, they correlate the third test with the second test, and see whether they come out to be the same. But normally we won't do that because you know why? It takes time to, because there are 2 administrations, it's not one. It takes the time twice, right? Or 3 times, for the same test. So that's why we don't have one more time, and that's it. That's good enough already. We talk about being practical. We have a time constraint in everything there. All right? But even some teachers say that I have no time for a retest. I have to finish my syllabus and everything. I have no time to do the retest. So because when there's no time for a retest, don't worry. Then there's another one. They call the split half test. That means you only have one test. Everything. I split half. A lot easier. I split half. That's easy. Okay, now let me go to the split half test. Okay. Now, the split half test basically is a measure of internal consistency. That's what I'm talking about, this word here. And this is the one where you can talk about using the Cronbach alpha, which I agree with what she said. The only trouble is if this one test also covers multiple constructs in one test, then if you do the Cronbach alpha here, you can do multiple Cronbach alpha for different constructs. So it's a bit troublesome. So over here, I try to make it easier. I want to make sure that the consistency is between 2 halves of the same test. So it's the different types of consistency I'm looking at. It's based of the two halves. Okay, so that's basically what it is. Now, in other words, how we do it, now here's the method to do it, okay? We have a test, and we divide into two equal halves. Now, there are many ways to divide. Okay, odd and versus even test items. I can do it that way. Okay, so the different ways of splitting into two halves. And then we try to correlate the scores of the two halves. Then, after that, we calculate the correlation using the Pearson, as I said before, okay, of the two halves. Now, but don't forget, your test may have, let's say, 20 questions. Your half will be about what? 10, 10. Am I right? It's around there. Okay, so 10, 10. Now, it's a very short test, though. 10 it is very short, right? So, because it's a very short test, your question need to be adjusted. Not quite accurate yet. You see, one thing about correlation, you need large numbers, right? But I only have about 10 items here. So what you do is that you need to adjust it. And how to adjust it? Because usually these correlations tend to be a bit lower, not as high. So because we need to adjust it, we use another formula to raise it up. We use what we call the Spearman-Brown formula. That's the one we use, okay? To double the length. Now, it's double the length to adjust the correlation. To adjust it, we double the length there. In order to estimate now the reliability of the whole test. Don't forget, we're not talking about the rate of the half test, we're the full test, right? The whole test paper there. So that's how we want to use this Spearman-Brown formula to adjust the correlation to estimate the reliability of the full test. You got it? Now, how do we do it? Let me have a word about consistency. Hey, Sue, can you get any water anyway? I'll run out of water here. I need the water power. What is internal consistency? It refers to how well the test item in the test measure the same underlying concept or construct. That's important. Only one. Our article work. Do they measure the same thing altogether? The first thing you have to talk about that. Okay? Now, what example of construct or concept? Take for mathematics. Problem-solving skill is a construct. Look at more the skill than the content. Fraction, percentage ratio altogether. These three always together in mathematics. I call it the three musketeers. Okay? Algebraic reasoning. One whole area. How to do algebraic reasoning? You can do it. Or circle literacy. Can you interpret the statistics? So these are the whole area in mathematics they can do it. Or for science, you look at students, how they can do scientific reasoning. In physics, everything about Newton's laws of motion. Everything you talk about that. So that's a concept and a construct at the same time. In chemistry, for example, you're talking about the Stoic geometry, the chemical calculation, all together. So this is one construct by itself. Or in biology, you have what? Photosynthesis, one big topic in biology, for that very matter. So that's how you talk about it. And if you talk about the internal consistency, it's supposed to measure all this individually using the compact alpha. And that's why I'll try not to do it for today. See that? Okay? For English language, reading comprehension is one area. Grammar and syntax is another area. Vocabulary knowledge and writing skills. All these are different constructs. You're testing it. So that's why I say, rather than doing this alpha compact, I rather it's easy. I want to know whether the two halves are really consistent. That's a lot easier for me to look at. Now the question is, how I'm going to split the test paper into two equal halves. Now that is the trick here. You don't know how to chop the two. Half. It's not like that, okay? Please don't do it in the half. Just like that, okay? Not that straightforward. Okay, now, that's how you split a test into two halves. Now this is a crux of the issue here. You can assign odd number item to one half and even item to another half. But when you do that, number one, make sure that you have to balance the level of difficulty. Don't make one side is more difficult than the other side. No, about the same. Balance the difficulty level, okay? And the construct of the items so that they are comparable to both sides. You can have one side all algebra, one side all geometry. No, you split out. Both sides have algebra, both sides must have, they have both somehow. You split very carefully. So that is how you do it, odd and even. So don't take another question on one side, you question on one side. It's not fair. Unless when you design a question with this in mind, yes, then you can do it. But if you don't have it, you have to consciously divide them into odd and even, in other words. You follow me? Or you can split based on contents. Identify different constructs or concepts in the test. What are the main areas there? Then ensure that each half contains an equal proportion of the question from each concept. Okay? Now again, keep the difficulty level the same on both halves. Then you calculate the total score for each half. That's how you were to do it. After you've done that, of course, then you are in for the calculation. And here it is a split half reliability. So we need to first calculate the correlation of the two tests. How do you do this one? Your Pearson will help you. Okay, oh, thank you. Okay. Oh, never mind. Thank you very much. Okay. Oh, never mind. It's okay. Never mind. Thank you. Yeah. Okay. Okay. This is my field anyway. The engine have no fuel. So the first part, to calculate the correlation, you use the Pearson to calculate the correlation of the two equal halves. But after that, that's not enough, because I said this one tends to give you a lower correlation, right? You need to apply the Spearman-Brown formula to adjust the correlation. And here's the formula. It's quite easy. You can see that the R here basically refers to the what? To the Pearson correlation between the two halves, right? It's twice of it divided by 1 plus R. And that's it. Now, you don't worry about how to come about this particular formula. There's a mathematical derivation of this formula here. Okay, I'm sure you don't go to that paper there to look at it, but they will just take it as it is. So that's how you calculate, the Spearman-Brown formula. Now, again, how to interpret the final result? That's important, okay? This is adjusted correlation here. Again, same as the Pearson, you have to have at least about 90% considered to be excellent. But anything between 0.8 to 0.9 to 0.89 is good. And anything which is between 0.7 to 0.79 is considered adequate. So that's how you do it. But below 0.79 is considered a poor reliability already. Okay? So in other words, the test may not be stable over time. It's just not. So that's the reason why you have to adjust it then. Now, I'll give you an example here. I think I have 10 students here. Let's make it easier first, okay? 10 students here. They order 10 test items. And here's the score which I have. You don't care what kind of this, but these are the 10 items here which I have here. Okay. So first of all, I take the total score. So I split into half. Now, assuming that these two sides are balanced in terms of difficulty level, I assume that I have an equal share of the concepts proportional on the both sides proportionally. Assume all those things first. So I will do that. So I will add up, total score for the first test, right? I will add up. For the student test, I will add up all those things here. You see that? This is student A, a 1, so they'll be, this one will be the first test, this will be the second half, sorry. First half, second half. I have all those things, so I add it up here. And then work out the Pearson. Then I work out the adjusted correlation there, which I get 0.87. So it shows a good reliability. The test is acceptable. So that's how you do it. Fair enough. It's a straightforward calculation, except the only thing is split into two halves. Now, as I said, I want to simplify this whole calculation here. But in your case, you may take your test paper, your split may not be exactly to be question 1, question 2, it's not like that. You have to adjust it. Make sure that both sides, the level of difficulty are the same. All right, you follow me. Now, once you have done that, so that's how you would do it then. Now you do. How about that? You do. Now, I think it's in a spreadsheet, you have this one. Same, I give it 10, except I have 12 items here, by the way. Now, with 12 items here, I split half, I would do it in this way, right? It's easy. All right, assume that I will sort out all my 12 items on two halves, A and B, okay? First half and the second half, and I will do it. Can you please work out the adjusted correlation using the Spearman-Brown formula? Oh. You should get something like this. I give you the answer here. Look at it whether you get something similar. So this one, your Pearson, okay? Pearson, get your Pearson R here, by the way. Okay, oh, we have got this answer here, by the way, hello? 0.76, correct?
Yes.
After adjust it slightly higher, you see that? So that's how you do it. Simple. Very simple. The harder thing is not about the calculation, because the spreadsheet can help do all the calculation there. The harder thing is to the split half. That's the harder part, by the way. Because you make sure that two sides are quite comparable, in other words. If the two halves are not comparable, then all the calculation will be meaningless. Fair enough? I want to show you about how to do the calculation there. But the actual effort spent is to be able to split into two halves nicely, that they are quite comparable, these two halves. Yep. No, sorry, no. You have to build that one. Quite simple, right? This formula is quite easy to build, right? Huh? It's a 2R divided by what? 1 plus R, isn't it? You see that? I have my formula here. You see that? My formula is right here. That's exactly, yeah. You could just keep it there, right? And just use it. Simple. Yeah. You create a function if you want to. Up to you. But it's not difficult to create them. Also, it's a very straightforward. That's a one line only. Remember, you take the spreadsheet and then copy, paste it, and that's it, you get it back also. Yeah. Okay, so that's how you would do it. It's not difficult for this one, for the split half test. All right, I wouldn't be spending so much time on this one. I think it should be end quite early also, in fact, a bit earlier. I can do this one. Okay, good. Since I only have 3. What else do I have now then? Okay, good. Now, I want to talk about this one. Be careful before I go there. Usually, I said the longer test will have higher reliability. A shorter test may have a slightly unstable reliability. That's one thing is sure. So if you only have test items there, about 5 for each half there, it can be quite unstable. And I look at some of the test paper there, usually you have quite a good number. You can have just about 10 items. Am I right? Usually it's quite a fair bit there. So it depends on what you're doing for the split half. Okay, now this will be the last one. Okay, how are we doing it? This one is about the inter-rater reliability. Now we are talking about the same test paper being graded by more than one rater. There are 2 teachers or more look at the same test paper. This is called an inter-rater. You can have 2, you can have 3. Doesn't really matter. But you can have more if you want to. Okay? So that's why it is called the inter-rater reliability. In other words, if you have 2 different raters or more, whatever that is, access the same test, is the score consistent? That's important. You want to come up with A grade, what's the F grade? Cannot be, heaven and earth. Hey, something must be wrong somewhere. Don't know what's that. Why A and B are so different the way, these 2 raters make it so differently. It must be quite consistent. Now, these raters, they must be independent. That's important. If not independent, there is a personal bias there. Please, no personal bias, okay? So in other words, what kind of a reliability are you talking about? We want to determine the extent to which the raters agree when they even the same set of test items. You find the number of agreements between the 2 raters. You follow me? So that's the meaning of it. Now, one important thing is they must use the same rubric. Cannot be different. So your rubric must be very clear. When they evaluate the test there. So therefore, your rubric must be clearly defined and specific with detailed descriptors for each level of performance and response. Please. You don't make your rubric is so loose. It's open to interpretation by different raters. Then you'll be very watertight with your rubric. You give it 2 raters there, you use it and do the rating and see how it goes. That's important. Okay? Now, and so therefore we have to do it after having the same, they will do the rating of the test paper. Now, what method do we use to evaluate this kind of what we call the inter-rater reliability? We use what we call the Cohen's-Kappa statistic, K, or Kappa rather. This Kappa. This is a K. It's a Kappa. Okay, it's good as a Kappa there. And we use the Cohen's-Kappa statistic to so-called evaluate the inter-rater reliability. Now, this kind of inter-rater is very good for what? For essay items. Very good. Essay is a first class. Don't do it for MCQ, short answer. No. For essay, this is a very good way of doing it. All right? Things that they have to write paragraph, explanation, or essay writing, anything. It can be used in science. It can be used in language. Math, I don't think they write grammar story. Okay? Math don't write grammar story. Yeah. Okay. Now the formulas are very easy. Oh, that's all. Now let me explain what this formula means. Okay? Let me explain this. This kappa is called the kappa coefficient. Now, you got a PO and a PE. These 2 are the probabilities. The PO talk about is the probability of observed agreement. How many test paper both agree on the score, the total score of that particular student, for example? They will see that, agree on it. Let's say you give me this test paper, you look at, I also look at it at the same time. Do we agree with that, right? That kind of a score we give to the student there. If you give very high marks, I give very low marks, something must be wrong somewhere. Am I right to say that? Okay. So, now, this one here, PE, refers to what probability of the expected agreement. What we expect. Observe what we see. What we expect is how we expect it to happen. It's called expected probability here. And once you get these statistics, by the way, now here is the value that you can see. One thing about statistics, you know what it is? Usually probability will never go what? Below 0, right? Or 1 and 1. Am I right? Yes. So therefore, what we have is that, maximum is 1. You can see that. So, in other words, if you get the kappa to be between 0.81 to 1, almost perfect. That means rate 2 rater weight the thing here. So that means, they are very consistent in the rating. You follow me? So they're quite similar. Now, if the kappa is between 0.61 to 8, substantial agreement. Strong, but not very almost perfect. Slightly, still good, not too bad. But if you're 0.41 to 6, to the moderate agreement, it's still quite okay. And this one here is only fair. It's a very borderline. Yes, sorry. I will show you the calculator. They will know later on. Okay, I'll show you. Don't worry about that. This is the terminology used in statistics. Okay, and yeah, I know what you mean. Okay, I will show you what it means later on. And don't worry about it. Yeah, I'm not going to teach you about mathematics here. Don't worry. This is not a mathematics workshop. Okay. Yes. Okay. For those who do mathematics, you should know that this concept is very similar to the chi-square distribution. But however, chi-square is used in biology also. Okay, to show you that. Yeah. Right? Am I right to say that? But however, don't worry. I am not using chi-square here. I guarantee you there will be no chi-square in my calculation. But I use something that looks like chi-square, but not chi-square. Okay, don't worry about the camera one. Now, if it's a 0.21 to 0.4, that's a very fair. Not the best, but the fair, okay? When it is very low, less than 0.2, it's a very slight, almost like no agreement there in a way. It's bad. So usually we aim to be a bit higher, okay? If it's a negative, that's even worse. Worse than the chance agreement. There's no chance agreement there. So that's the whole issue here. This one, chances are it will not happen. If it happens, it's very bad. Something must be very wrong. Maybe with the rubric is not good enough. Am I right? That could have misled the two raters. So the whole issue here. Now, okay, don't worry, I will explain all those things there. Don't worry. What's the expected agreement? What's observed agreement? Now, okay, we talk about essay tests of 10 students. So therefore, 2 teachers, A and B, access this same test paper, okay, for the 10 students there. Now, let us say the maximum point of each essay is 5 points. Let's say, okay. Now, I don't know about how many marks you assign to the essay test. Who can tell me? What? 30. Okay, good. Now, I use small number of what? Okay, wait a minute. Use 30. Very good. But of course, that means the grade score can vary somewhere from where? From 0 to 30. Fair enough. You don't use that. Because if you talk about 2 raters come up with the same score for the same student, exactly, chances are very low. It's a very low. It's almost like when you have 2 sets of, let's say, number balls. you mark from 0 to 30 on both sides. You pick one ball here, you pick another ball here. What's the probability they have the same number? It's very low. Let's say 10, 10, good, okay. Or 25, 25 is good, but very low. It's not luck, right? You're saying, okay, fair enough. That's called the random selection. You select randomly. It's impossible, right? So what we do is that you give a rating scale. For example, yes, okay, look, I use your 30. Let's say that you consider anywhere from 25 to 30 is A grade. For example, I'm just using it as an example, okay? Let's say maybe you want to use about what? You want to use about, let's say, 20 to 25 to be the B grade. Now, I don't know how many you want to break it down, okay? Maybe from maybe you want to use from 10 to let's say 19 to be the C grade, and anything below will be less than that will be the D grade. For example, okay? This is less than. This is what? This is less than 19 to be D grade. Just for example's sake, okay? That's about all that. That's what you want to capture. Or you can also put it into numeric. It doesn't matter. You can put this to be, let's say this will be 5 points, or let's say this will be 4, let's say it will be 4, 3, 2, 1. Equivalent grade. It means 4 means it's the A grade, 3 means the B grade, for example. You guys use the alpha or use numeric, it makes no difference. What you want to do is whether they agree, that's all. So in other words, if the student, one grader give her, let's say, 25. Another grader give the same student for the essay there is, let's say, 27. We treat it as the same A. Am I right? It's the same A, in other words. So that's what we do. So don't go to the detail of that. You do the rating scale like this. That's what I'm doing here. Okay? So I said 5 points. Of course, you get 4 points up to you. Okay? I just use 5 points for the sake of illustration. So I consider if the two agree, that means what? It's a poor, fair, satisfactory. Now, this one is not about what? How good the essay is. It's about how good it's a number of agreement. This agreement I'm talking about at the end of the day, whether they agree or not. So no, sorry, this is about the grade. Sorry, this is about the grade of the students, how they would do it. I will consider this to be, let's say, if a teacher A mark 1 for this one, it's a 3, for example. This is the so-called base of rating scale. It may fall, let's say one teacher may mark around this one here, one may mark around here. Am I right? So it will become 3 and 2, for example. So 3 and 2. So that's how you would do it. All right? Yeah. Okay. So therefore, you have a scale here from poor, fair, satisfactory, good, and excellent. 5-point rating. Up to you. You get 4 or 3. Doesn't really matter. Now, of course, in this case, I wouldn't put a maximum point. It's only 5 points. Like, that's easy for the thing of calculation. Okay, so now the teacher start doing all those things here and they convert into the rating scale. Fair enough? So you can see that student 1. So, for example, student 1, 3 and 3, right? So that means, this student had the same rating for the two teachers. Fair enough? This one, a bit different. This one give a perfect score, this one very low. I do it in this way here. Now, after I've done that, I have to create what we call the condition table, which is a 2x2 table. You get a 2x2 table here. Now look at here. In this table here, that's why the word sounds like chi-square, am I right? This table. Chi-square, this word is called this table, by the way. Okay, now, what I do is that A give 1 point. Okay? B give 1 point. A give 2 points. So I will do that. You see that when I say B give 2 points. B give 3 points. So that's how you read this symbol here, which I'm writing out. You see that? Now, how to tabulate it? I will count among the grading. How many times do they agree? For example, if I were to look at how many times do they agree that both will give 1 point, 1 and 1 point, none. So 0. Look at this one. A2 gives 1 point. B2 gives 1 point. Right? That means there must be something must be here, right? Oh, no, B gives 2 points. So B is 2, A is 1. So I will find B is 2, A is 1. Do we have 1 here? B is 2. Oh, 2 again. Just 2 again. Number 3. You see that? So I count. Okay. So that means this here is one agreement. Fair enough. So you count the number of agreements. In other words. Okay. So 0 means no agreement. Now there's something 2 means okay. Let's say 5 right. 5 means what? There are 2 students who both score. Give them 5. It's a 5 and a 5. So there will be 2. So you do this one here. Now after you've done all this, you have the so-called the row total here. This is a column total. You add up all those together, put all those numbers there. Fair enough? You add all this, it should come to exactly 10, by the way. This is important. Your row totals, your column total must be the same, in other words. First thing. So first of all, you have to do up this table. Now, there are 2 probabilities. What's the probability of the observed agreement? How many times do they agree? This is my P0. Now, what's the formula here? It's the number of agreements over total number of observations. How many observations? 10. Am I right? Since I only 10 to observe 10 times. How many agreements? It's only this diagonal. See that? Similar, right? So add up all those agreements. So you can see that it will be 0 plus 1 plus 2 plus 1 plus 2. Excuse me. I got 6 over 10. The probability is 0.6. That's how I get my observed agreement. It means based on what I observe here in the table, I pick up the number of agreements between the 2 teachers. Got it? I still have another one to calculate. Probability of the expected agreement. Okay, now this one. How to calculate the expected agreement? The PE is the row total in the I row times the column total in the I row. How do I do that? Watch out, 0 times 1. See that? 0 times 1, 3 times 1. 4 times 3. 1 times 1. 2 times 4. That is the expected agreement. Very similar to chi-square up here. But sorry, I said I don't use chi-square. I said it looks similar, but not chi-square. I said that already. So, okay, now after I've done that, life is a lot easier. Then what you do is you divide total by the square of the grand total, which is 10, right? The 10, right? You square the 10. So you get what? 100 here. This one add together to be 24. So it becomes what? 0.24. So now you get these 2 probabilities. The observed probability, the expected probability. Now I plug into this Cohen-Kappa formula here. And that's quite easy, by the way. It's just straightforward. You know, so PO minus PE divided by what? 1 minus PE. You bring it out, and that's what it is, 0.46, or 47, sorry. Now, what does that mean? That means what? There's a moderate agreement between the 2 raters. Very moderate. That's how you do it. Okay. Again, thanks to the spreadsheet, they help me do all the calculation there. I don't do it manually. The only thing manual is to what? Enter all the data for the first time, and that's it. I let them pick up everything. This table actually can be generated easily using the Excel spreadsheet. I'll show you how to do this one here. Fair enough? Are you clear about this whole calculation? Okay. Now you do it. Your turn now, not my turn, your turn now. Okay, I'll show you how to do it, don't worry. Okay, now. I got 15 students. They've taken a same essay test. So all the 15 essays there. And there's also a common marking scheme given to the two teachers. Okay? Now let us say that I use a 5-point scale. The Likert scale here, okay? 1 to 5. Doesn't matter whether 1 to 5, 1 to 4, you decide that doesn't matter. Now, so these are the rating for the two teachers. So the question is that, how am I going to evaluate the inter-rater reliability using the Cohen-Kappa? Well, that's how we do it. So there's a whole question here. Now, let me show you how to do that one. You don't have to worry. I give you the data already. I will show you how to do the calculation. Let me pull up my spreadsheet first. Where is it? Open up? No. No, this person, no. Let me close this one. Okay? Now, it's the same. Okay, listen. I'll show you how to do it. This one, basically, I've explained to you how to do this one. If there's no agreement for this one, I put a 0. That's all, right? Of course, you could do it manually. But you have too many students there, there's a lot of work. So I would let the system do it for me then. How do I do it? Now, let us take, I will take one, okay? Let's say I'll take the first one. You look at the formula. Let me enlarge my formula here for you to see. Now, what does that mean? That means there must be one student where both raters give 1. Am I right? For the same test paper for the student there. Okay. Now, that's why you see that. You see what happened is that I will have this one. Count ifs. Not count if. Count ifs with the S there, okay? Be careful, huh? Count ifs. Bracket. What do I have? I will have B2. Sorry, B2 to B what? To B16, comma 1, comma C2 to C16, comma 1. Now, let me explain. What does it mean? Now you are going to find that the two raters give the same score, right? 3 and 3. And you want to count how many of them. Now, B2 to B16. I don't have it. This is B2, right? B2 to B16. These are the scores given by teacher A. I put it there. B2 to this is a range of score given by teacher. I want to pick up what? She give 1 point. The second one is what? C2 to C16 is teacher B. Follow me? Also give 1 point. How many of them give 1 point? You do it this way, you see. Count if, talk about a compound condition. 2 conditions rather than 1. Count if, you have this earlier on, you see the count if. It's only 1 condition, only. But count if, I have 2 conditions. You see that? So that's a bit different. I count how many times do they agree. So I will do that. So I will do that. I will start putting in now. If I talk about the zero now, what does that mean, the zero? Let me take this way. That means when A assigned 3 points, B assigned 1 point for the same student, how many? Nothing. But in your setting, it should be the same though, by the way. If I want to, this will become what? It will become a 3. It will be a 0. It will be a 1. Am I right? So if there's nothing there, it will turn out to be 0. You follow me? So these are the score you put it inside there. Now, I use numeric. But what if you use alpha, A, B, C, D, instead of numeric? Can still be done. If you use alpha, let's say I will use A, B, C, right? What I would do is I can replace this by alpha. Let's say I talk about grade A. I put a grade A, double quote. A, double quote. That means both raters give a common A to the student for this essay. If one give A and B, then it will be like, maybe this one give B. Then I will see how many agreements are there when this teacher A give B grade and teacher B give the A grade, for example. I can also do it in that way. So it can be either alpha or it can be numeric, up to you. You follow me? So that's how you would do it. And after you have done that, then this one is what? This one basically, I'll show you this one here. Okay? Now, after you have done that, you do the sum. This one is quite easy. You add up all the sum here. These are the row sum, these are the column sums. Alright? You make sure that it must give the same answer with 15. Because I only 15 students here, by the way. Fair enough? Only 15 students here. Okay, after I've done that, of course, then I can start calculating my observed probability, expected probability, and finally, it's my kappa. Now, how do I do that one there? Okay, so I'll show you how to do this one. This is how I do it. What do? I take the what? The diagonal. You see that? This is the diagonal I'm talking about. This is the diagonal. 1 plus 2 plus 3 plus 2 plus 2. Why? Because that's where they both agree. Huh? What type of thing? Sorry, one time over. No, okay. No, let me explain it first. Okay, it's a minute. Don't worry about it. Okay, I want to show you how to get this PO. Basically, you take where they agree, the number of agreements. Both markers give 1 point. Both markers give 2 points. Where they agree, you add all those things there. This is called the observe. Okay, this is called the observe. Where they agree, you divide it by the total with what? 15 students. Right? 15 students there. Okay, 15 students there, and you will get the PO. Is that what you're saying? This is a mistake here. Do I add incorrectly? Correct what? Oh, eggs in. Egg, okay, I make a mistake here. Okay. 7. Okay, correct. Thank you very much. I think I make one stupid mistake there. Okay, good. Good observation. 8. 7. Am I right? 7, huh? Correct. Good. You see, one thing good about it, when you make a mistake, you want to change it so you can change it by yourself. Huh? It's quite nice. Huh? Okay? So you have to read through the whole, just change the error there. So you will get this one here. Alright? Now, this one is a bit complicated because this one basically is the probability of the marginal product. I show you this one here again. That's how it looks like. Quite long, this one. Basically, you're talking about, watch out, this times this, plus this times this, plus this times this, plus this times this, plus this times this, divided by what? Square of total. Square of total, correct. Yeah. Square of total. Those who have taught statistics recognize that this is a product of two independent events. Yes, because there are two independent raters. You find out, yes. If you look at it very closely, it is. But I don't go into it now because I'm not teaching stats now, okay? But basically, that is a product of two independent probabilities. Okay, never mind then. Don't worry. Okay, so that's how you get this one here. Now, once you get that one there, the last is easy already, which is the kappa. Kappa is simply this formula here. Am I right? So, this minus this divided by 1 minus PE. And you should get it. The last one is quite easy. All get the same answer? Same as mine? Okay, but you're going to build up this one first. That's important. You build up this one first. Now, once you build up there, by the way, if anything needs to be adjusted, here, let's say grading is not quite right? You adjust it. This table, everything will be adjusted by itself automatically. Because they're all linked together nicely in this way. So save a lot of effort to redo all the whole table. But how? It will affect the table here, of course. No, it will. No, it's still the same. What I will do if I now? Okay, let's say an argument. Okay, if I were to change some numbers there, let's say I will change this one to, instead of a 3, I put a 1. How about that? You see what happened, huh? Things change. It changed already. You see that? If I do that, it will change. I put a 2. You see what happened, huh? You see? It will change. You know, if I put something, it will change. So I can keep the same table there, but it will straight away do all the calculation there interactively. So you only spend one time effort to create this table, and the more you change the score here, this automatically will be changed by itself. So now your kappa is a 0.57. How to interpret these statistics? Is it good or bad? What say you? Come on, look at my notes. What does it say? .57, what does it fall into? 0.57, it falls into which range, by the way? It's a moderate agreement, am I right? So that means there's a moderate agreement between the two raters. Of course, the higher the better it is, but at least it's moderate. Okay? How is it so far? Hard. Now my slowly. But once you do the table, it's a lot easier for you to do the intake. First time is hard, yes. But slowly do, yeah. Because I know the time is very short here. You have to do it, in the sort of short span of time. Fair enough, okay. But don't worry, you get all the formula inside there. You're going to go back, you can still play with it, Try to get used to it slowly. Okay. That's it. This is only good for essay items. Yeah. Can also. Yeah. Now, let me summarize all these methods here. Hello? So far, for the whole test, we talk about the reliability, we talk about these 3 types of methods we have. First is called the test and retest, right? We try to evaluate stability, by the way, of the test score over time. Are they stable enough, the test score, number 1? Okay? If there's no significant change in the student's knowledge or ability between the 2 tests, hopefully there's no very big change between the 2 there. And they use the Pearson product moment correlation coefficient to calculate this one here, to establish, whether or not there's a good test-retest reliability. The split half is actually meant for the internal, to measure the internal consistency of a test instrument. You split into half, Hopefully, these two halves are comparable halves. Must be comparable. I can say that, okay? Yes. Then you use the Spearman-Brown formula to adjust the correlation. And last, we talk about the inter-rater. This is a very good talk about you have to access agreements between two or more. Why do it can be more than two though? You can have 3 or 4, doesn't matter. But just use 2 for the illustration, okay? These rater are actually independent and they must use the same scoring criteria. Cannot be different. Same scoring criteria. And to do that, whether you find out whether or not there's a good agreement between the two raters or not, use a Cohen's kappa to do that. So this basically sum up these 3 types of reliability tests.
If let's say the inter-rater, you said can have more than 2 raters. If it's 3 raters, what is the contingency table going to look like?
In that case, what you would do is that you have to build up 2 different tables there. Okay, so if you want to do it that way, it can be done. But usually people use only 2. It's a lot easier to do that. Because there are multiple, you have more and more to handle. You have to combine it all together. So it can be done still. I won't say it cannot be done. Okay, so yeah, that's one way of doing it then. But we try not to complicate the matter. I think most of the time, people, for practical purposes, people use only 2. 2 is good enough already. Actually, if you have more than 2 raters, I think it will be quite low, the agreement. Not easy to get all the more you have, the harder it is to get all the agreement. Am I right? Oh. Okay, they don't tell us how they were to do it. It's almost like, okay, that's a good question there. But I can tell you how I have done it and how my friend in Singapore have done it. Don't forget Singapore with the PSLE questions. Now, they get all the teachers together. Not all, but they select. They select a few from each school that they will do the grading for the PSLE. After the PSLE exam, let's say whether math or science or English, anything, they get it all together. And there will be a briefing given to all these raters. They all, by the way, they have to go to one center and they'll be locked in there. Sorry, you can leave any place. You must stay there. Okay, they can go for lunch, but only go to the that's a canteen. They're supposed to go, or they cannot go outside. But it's all inside there. Because nothing to be leaked out. It's a national examination, Don't forget, okay? So now, don't forget, we talk about this PSLE. We got more than tens of thousands of students taking the PSLE every year. The whole country, right? For the whole country, so they're doing the marking. They have a very rigid rubric score, very detailed. And therefore, there is a one chief marker, brief them what they would do. And they will do the rating. By the way, they will never do the rating on paper, on the screen. Because all the tests have been loaded to the screen. So on the computer, they just load up, they can look at it, they will do the grading on the screen. So that's how they would do it. If there's any discrepancy or anything, look at it. By the way, the chief, the head there, to look at what they're doing. There are lots of helps, by the way. In case the teacher cannot see certain answer, whether right or wrong, they raise their hand. They'll come around to help them to see whether or not, they will agree with each other. So there's a one way that they are doing it. All right? So, now, and to make sure that the rating must be consistent, obviously. So that's how they would do it. And also they will divide them out. They won't mark the whole paper, no. They must select it. Let's say you mark MCQ, I will mark open-ended question or whatever that is. So they will separate them together. It's not easier for them to manage. Okay? So that's how they will do it. I've done that in my university days. I was one of the markers in the university for the undergraduate students, mathematics. And there was about 20 of us in the one room there, We marked for the whole first year undergraduate, let's say calculus. We're talking about easily about 500 or 600 students taking the first year calculus in the final there. So many markers, so we are the one. Now that one, unfortunately, we do on the paper, not on the one. So what we do is this. When the chief a marker there, they will assign. You do mark question number 1, number 2, number 3, so they will all mark the same. That's a lot easier. In case the 500, right, they may let question 1 to be marked by, let's say, 3 or 4 markers. 2, another 3 or 4 markers. So we'll do this separate out, then they'll collate them all together. So this is how they would, it makes it consistent across. And they want to make sure that those who mark number 1 have the same marking scheme. Can it be that? If any discrepancy, they'll throw it up there and they will discuss how to resolve it as such. Very rigid. We have to do it that way. And it's very objective because you never mark the whole paper. But of course, like you're sitting here, teacher will mark the whole paper there. Fair enough. And that's the reason why it's good to get 2 teachers mark the same paper, okay, and try to correlate how far do they agree with each other. So that's the whole purpose of the iterator. Yes. All right. Yeah. By the way, in the Cambridge, everything is marked online. There's no paper to log with. What they do on the paper, then everything upload to the computer or already. Yeah. So that's how they would do it. Same as Singapore, every upgrade to the computer. They will never handle their paper there. Usually they will mark for a few days. Not one day cannot finish all. Yeah. So they will have one group for the math, one for the science, one for English, or for anything else. They separate them all together, different centers as such. Okay, so that's how they would do it. Now, I will talk about sample size, okay? Retest, test and retest, 20 is only adequate, I would say, right? It's only adequate, okay? Try not to go beyond below that. About 1 to 2 weeks apart from the entry of the 2 tests. That's good enough. Or 2 to 4 weeks for the midterm test, if you want to do it that way. Of course, prefer with 50 or more, rightfully, but if you don't have it, it's okay, a bit less. So you can see about 20 to 30 is around that for all the 3 methods that we are using here. All right, so therefore, that's basically what it is. For split half, minimum 10 to 12 items. They're very, very minimum. The more the merrier for the test items there, but don't have too few then. Again, you prefer the bigger sample size. And for the iterator, you make sure that the data are independent. Okay? You may get another marker from another centers. Now they're totally independent because I have not seen this before, never seen the paper before. They can do the marking. It's quite independent as such. And they must use the same scoring criteria. So that's basically, about the sample size and how you would do it. Let me summarize this for today's workshop. What do you think of the test instrument that you administer to the students there? Okay, and this is my thoughts for my closing remark. I will say it. Someone else will do the talking on my behalf here.
To summarize this workshop, a test instrument is more than just a diagnostic tool for evaluating students' performance. It also serves as a reflection of a teacher's pedagogical flexibility and effectiveness in a dynamic classroom. This dual role highlights the importance of continuous professional development to help educators adapt to the ever-changing landscape of education. In this sense, a test instrument is a double-edged sword. It not only measures student learning, but also reveals the quality of the test itself and the teacher's assessment and instructional skills.
You heard that? Suddenly he wake up, the speaker. So, therefore, what you assess the students, in return, the response may assess you as a teacher. That's a fact. It reflects the way you deal with them, how you teach them. Because they talk about your teachers, how you assess them, how's the instruction in the classroom. This whole idea. So therefore, a test instrument is an important thing, okay, for yourself and for the students at the end of the day. If you have a good test script, good test items there, please keep them, honestly speaking. Next year, you reuse it, but you can change the data, the number, you can change the context. Reuse it. This is a good test item, I can use it over and over. Because students in different grades, at different time, they may not recognize the question in the past years. They cannot recognize it, to be quite honest. Yes. So that's the message I want to tell you then. Okay, hopefully I think you can set a good test paper for teachers there. Have to do good test. I heard that your Your paper will be used in other centers though. Since other teachers don't have to do all the setting of the test paper, they take yours or what you set, and then they will use it on their own students there. That's why I. Ah.
They do pick papers the past year for past year papers, so they will choose questions from there.
But that, yes and no. Because how they choose, that's important. If they choose the wrong one, they will choose all one-sided or whatever that is, or all the difficult one, It's not very well balanced. It's wrong, You see, there's so many factors to consider when you want to design a test paper there. Put it this way, it's not easy though. You see? It must be fair. You can anyhow randomly pick any question here and put together. That need not be a good test paper though. By the way. And even if you take the Cambridge IG test paper rightfully in your test there. By right, you can take it wholesale. You're going to modify it. Don't take wholesale. Please. Else, the school will run into problem. Because all the questions are copyrighted. Don't forget. I use lots of Cambridge questions in my textbook, all modified. I said, it's a good question. I like to put it in my textbook. But Cambridge, one way is, unless the publisher seeks permission from Cambridge to use, yes. Then in that case, the textbook, there were permission from Cambridge, University Press. They put it there very clearly. Then it's okay, then you can use it. Same for science or whether it's the same. You can do that. But if you don't want to seek any permission from all this copyrighted material there, you still can use, but you're going to modify it. Quite easy to modify, to be honest. I'm expert in modifying all the questions there, okay? They were trying it this way, I put it the other way around, so what? You got A, B, C, X, Y, Z, then what? You want to find the area, I would say find the radius. So it's okay. You want to find area, I want to find the radius. So what? Nothing wrong with it. So these are the kind of a way that you can change it then. And for science, the same thing. I can rewrite the question. As well for chemistry, I can change the whole equation. The whole chemical equation, I can change it to something else, another different compound. But similar type of question I can ask, but change everything. So it's easy. So that's how you do it. But the point is not whether you get it from any source. The point is that you make sure that you produce good quality test item. That's the key issue here. And the difficulty level should be a wide range. Can it be all difficult or all easy? Spread out nicely. So there's a whole issue here. If all the students pass all the tests with flying colors or fail badly for the test there, something must be quite wrong with the test paper, by the way. Am I right? So put it this way. It reflects on you, though. How good is the assessment skill, okay? That means you know how to assess them carefully. Yeah? Oh, talking about that, I remember one incident in the university. One professor, I can't remember which university there, it happened in Canada. For the final, they give A for every student. All A's. Oh, happily, okay, A, leave the class at the end of the semester there. And you know what happened to the professor? He got fired. Immediately, the university fired the professor. Thank you. So, be careful. So, for the university, if you set the wrong paper there, you may get fired by the university. Yeah? That's quite dangerous. So, please don't set bad paper there. I still remember in my good old days in the university there, there's one professor, I also get very worried about him. You see, in the university, with lots of proving questions there, lots of proof. Prove this, prove that. Now, usually I say, prove this, I can prove it. But you know what's that? Prove or disprove. Oh my goodness. He give you I give you a statement there. Can you prove it? You cannot disprove it. So in that case, that kind of question can never be wrong. I can set the wrong statement there. If you think it's wrong, disprove it. If you think it's right, you prove it. You say prove or disprove. That is the hardest question I ever answer. First of all, you make a decision. Should I prove it? Is it, do you think it's correct? I must prove it. You think it's wrong? I must disprove it. How? If I have to prove it, I know, it must be a correct statement. I have to prove it. That's okay, right? If I give a wrong statement, say, disprove it, I'm supposed to disprove it. I say, no, prove or disprove. That kind of a question requires what we call decision-making skill, how to make a decision to do it. And within the time constraint, you're supposed to answer that kind of question there. That is hard. And they love this kind of a test question. I said that for one semester. That's enough already. I said, thank you very much. Yeah. So I got all kinds of different types of professors set different types of test papers there. Okay. But some of them are actually quite challenging. I got one in mathematical logic, you know. That's, the final is a take home for 1 week. Take home. I give a take home for 1 week, hand the results next week. I look at the questions there, none can be answered by any means. You have to really figure out how to answer that question. You can flip any books, you can go to search and write and don't know how to look for it then. That's his own creation and that kind of, by the way, it's about logic. So logic is the hardest thing, by the way. If you learn to learn mathematics, to learn logic, that's the hardest thing to learn. Very abstract. Yes. So, okay, so I hope that today you find something useful, you can pick it up. Okay, I know it's a bit hard because the time very short for you to abstract, you know, slowly you can pick it up, you can discuss among your colleagues here and there, and then, you know, figure out that. Now, you keep all the spreadsheet there, you can modify it in time to come, you can use it with your own data and see how it turns out. And you'll be surprised about the test items that comes out, how it looks like at the end of the day. The test paper, how it looks like. Okay? All right, good. Thank you very much for your time. I will see you then. Okay.